All right. Getting set up here. You guys should be able to hear me. Oh, well, Ranger Cam is not up, so I'll leave that down for the night. I typically give you guys about to the end of the first song before we start too much in earnest. We're going to do something fun tonight. Got a lot of stuff we could do, but I think what we're going to do tonight is a little more fun. All right, let me go fix the name of something real quick before we get started here. All right, get started here in a minute. Why does Twitch not know I'm live? All right, Twitch knows I'm live. You guys should know that I'm live. Hopefully my camera figures out that I'm live. All right, let's start it up. Let's start it up here. All right, so what are we going to do today? We are going to start with something that's kind of fun. We're going to do the, this comes directly from the Professional Linux Users Group book, and I am going to just kind of do a cadence that I used to do pretty often around here, which was just going through our labs. So I kind of entitled this the Beginner to Enterprise or Beginner to Expert Linux, in that we start at the very basics, right? So if you've never been in Killer Coda, here is a link to get you started. Drop into that shell. It doesn't cost you anything. You can just go through a Google account or something like that. And they don't even bother you too much with emails. I don't even think I've ever even gotten an email from those guys. They've never charged me anything. I've been building labs on there for almost 3 years now. So I think it's a great site because it gets you guys in there and we can talk about Linux as we kind of go. So let's talk about on the right here, the lab is called System Checking. On the left, it's called System Checking. And what it says is over here, you're a new systems administrator at a company. You've been tasked with finding out information about a set of servers that has little or no documentation to it. That's probably the most sysadmin thing I may have ever even heard. You find yourself at a command prompt and you need to find out what type of system you're working on. You know, what's the release version, what's the kernel version, how was it booted, and then use the solution down here to find the answer if you don't know it. You can always just, one of the things about the way I wrote these labs is it just walks you through, because I'm a big fan of just seeing the things happen over time you're going to absorb some of this stuff. I really do believe that. So there you go. And Trevor's over on the YouTube side, and Kang over on the YouTube side. How's it going? And Ployd and Zorgal over on Twitch. Well, yeah, we're just gonna sit here and work on labs for a little bit. The wife's out of town; she'll be back Sunday, so I'm just doing labs and working on stuff. So on the right, it says your task is to determine the operating system values of a running Linux OS, execute commands, and evaluate output of a running Linux operating system. Condition: given a bash prompt, complete in the allotted 60-minute time. You got 60 minutes by default. Standard is to work through the lab at a pace that matches your learning goals. Again, earlier in the book, we talk about, if you guys ever want the book, there's basically just blow through labs in 10 minutes. There's do it in 30 minutes and take a little more time. And then there's some going deeper type questions that might take you about 60 minutes to answer. That's the way I've kind of set these labs up. So let's start over here in the lab and say, first we check what version of Linux we're on. Well, the killer code of labs were just recently updated, so now we're on 2404. We were on 2004 before, but over here on the far right it says what useful information do you see from the command cat etc splat release? Why might you need to look at this information? Well, as an administrator, if you are tasked with supporting a set of servers, you're going to want to know what those servers are. And you might say, well, Scott, after time I'd know them, or with documentation I'd know them. Sure, if that stuff exists, sure, if you're not brand new, but there's going to be some point where it's the first time you've ever logged into some server, right? So, here it is. Here's the type of server we're dealing with. Things I care about out of here tend to be the version, and if it's long-term support or not. That's the LTS, right? That kind of stuff. Do we have a support contract and those kind of things? By the way, this is the first thing anybody's going to ask you if you do have a support contract. What version of the OS are we talking about? Because that's going to determine what documents they go and look at. It's going to determine what you look at, all that kind of stuff. So the next thing is we check the kernel version, so uname-r. There's a bunch of different uname commands. So uname by itself will give you that we're on Linux. Uname-a will give you everything out of there. Uname-m will give you the architecture, which is also kind of important. So we know that kind of stuff. And then we might want to see how the system was booted. So maybe I clear the screen and I type cat proc command line, and it tells me about the kernel image, how this system was called, right? So this is just maybe important things. Maybe it's your first time ever at a command prompt for a server, and you might just say, well, these were all useful commands. I could see the information about the system I was on. I could see the kernel information about the system I was on. I can see how it booted. I don't know everything about how it booted, but I understand that that's where I'd go get that information, right? Another one that's really good here is dmessage with like a head. So you pipe it through head, and that will give you the first 10 lines of your dmessage. Now a pipe, for people that are newer, right? When you type a command in, you call the command by name, right? So we're calling dmessage. And dmessage wants to come to standard out. It wants to come to the screen. So as it starts to come to the screen, this captures that standard out and throws it into the input of head. Head is another command, which by default only shows the first 10 lines, right? Now you can modify the way head works. You can modify a bunch of things, but suffice it to say for now, we're just seeing the first 10 lines of dmessage. And right here, here's our command line of how the system was called. If we needed to dig in deeper on this for some reason, let's say, we just didn't like the way that the image was booting, we'd cd over into boot grub typically. And then in here, we'd find something like the grub.cfg. We can just paste that if we want. And then down in here, we would be able to see where it was setting those and how that was getting called to actually call the kernel right here, right? This is maybe a different version. Yeah, this is the... Actually, is that the kernel version we're on now? Oh yeah, okay, so that's the kernel version that we're on. So that's our command line right there as it gets called. Also, it tells us the init.rd, which is the init RAM when the kernel first comes up. You don't need to know all that stuff when you first start, but the point is, all this information's here for you to pull out of the system. All this is, people like to call that gleaning the information out of there, right? So we can dig a little deeper. We can go in and we can look at how this system is actually being used. And I kind of just jump you into a bunch of commands here. So this lab really is just about commands and understanding the system a little bit. But over here, we might say, what is the information that you see about the kernel with uname-r? You see the general version. You see this is the major version 6. Here's the minor version 8. And then the patch version, as it were, is 0-51. And you'll see these patch versions move up often as patching is released into the kernel. All right, somebody wants Ranger check, but unfortunately Ranger cam is down. So I will have to show you guys Ranger here in a little bit. He is, so I'll show you guys Ranger cam. Ranger cam is down because it didn't get plugged back in, but I will get it up here in the next hour or so. I'll pull Ranger cam. I'll go put it back up. So the wife had Bunko a couple nights ago over here. If you guys have never seen Bunko, it's this game where just a bunch of people throw a bunch of dice. And the wife was playing it with her friends here. So they took down Ranger cam so they could use that room. So it'll be fine. We do a command like uptime, and it tells us about the system a little bit. And then over here, what's the information shown in those last 3 numbers and why would we care? So maybe we need to go read a little bit about how uptime works. If you don't know where to read about a command, we say man the command name. So man, to read the manual for uptime, will tell us about uptime. And it'll tell us that those 3 numbers at the end are the load averages for the 1, 5, and 15 minutes on the system. They're aggregate load average numbers for how many use, and the system load averages are wait time for the processors, right? That's what those are. And it says right here. So the average number of processes that are either in a runnable or uninterruptible state. A process in a runnable state is either using a CPU or waiting to use the CPU. So a rule of thumb, a general rule that we use as engineers is this. If I do an nproc on a system and I see 1, it's only one CPU. If I do an uptime, if the number here is greater than 1, if it is 1 or greater, there are processes that are waiting for that kernel. If it is less than 1, then there are then the kernel is being used up to the full amount. So if this nproc had said I had 32 cores in this machine, I wouldn't care if this said 15 in it. But I would care if it was 15 right now, because that would mean that there's a significant amount of processes waiting for processor time, if that makes sense. And that is the general idea of what you're looking at this for. Okay. So anyways, we say vmstat. Boom. Vmstat will give us some information about the system. By default, if you just do the command vmstat, it will give you the output 1 time in the current slice. If you do the number 1, it will give you every 1 second forever. If you give it a number at the end, like 5, it'll give you every 1 second for 5 total iterations of seconds, right? And then you don't really have a step with this one. That's all you really need to know for these. But what are we seeing here, right? What is vmstat showing us? Well, a little hard to read when it's collapsed in like that. But it tells us the runnable and blocking processes. So this thing's actually very useful. If we had a higher load average here and we wanted to see if we were actually waiting, vmstat would be useful for that. It also tells us how much memory we have, if we have free memory or if we've used it all up. Very important in the case of databases and stuff, because databases, they want to take everything and hold it in memory. Even if they're not using it in real time, they want to hold it all in memory. We don't want to, on modern Linux systems, be swapping in or swapping out. That's always about 1/100th the speed of our RAM going out to disk. And you say, well, what if it's a really fast disk? It doesn't matter. It's still a disk. So it's 1/50th, but it's still much, much slower than being up in RAM, right? As far as that goes, we do not want to be swapping in and out. There are some systems where people play a game of building a RAM disk and then swapping to RAM, and okay, that's fine, but that's kind of gimmicky, because then you're trading against the RAM you have. Also, it doesn't work well in the high performance compute space, because in the high performance compute space, we want to have the exact same number, the exact ratio across all of our servers of the number of processors to the memory. So we don't want to be playing around with swap in the RAM space if we can avoid it. Most of the time, you will see people disable swap on high performance compute type systems. You will also see swap does need to be configured on like Oracle databases. It's actually a requirement, but we do not want to see swapping, guys, in a system. If you're seeing swapping, the swapping is not analogous to thrashing, but you can almost think of it as very similar, right? And when I say thrashing, I mean the system's doing a lot, but it's not getting anything done, right? We don't want a system in that state. So swap in and swap out, always considered bad in the last 15 years of me doing this. Maybe at the beginning we still did some swap, but not in the last long while. IO tends to mean that it's commits back to disk typically. And then there's some system information and CPU information that you can look up. I have all this information in a different slide deck, but we're not really going too deep into that. I'm just kind of showing you some commands. So what are you seeing here? And if you really want to break it down, you can man VM stat, and you'll see a whole bunch of information down here around what all of those things mean, right? Yeah, if we're writing in and out to a block device, so one of the block devices on our system, if there's interrupts happening, and that's context switches are slowing down actual flow of data, so that's always there. And then here's your CPU information, so that's useful, right? But maybe you don't need such this is what we might call a 10,000 foot view of the system, because this really is truly just the whole system. This is not any one process. This is not any one any one thread going down through the system. This is simply a 1,000 foot view, or 10,000 foot view, as people say. Like, you're looking down at the city and you're seeing traffic flowing around, and you're like, all right, cool, traffic's moving. All right, good. Colchis, if I didn't say hi to you, hey, how's it going? We are just working through labs, and I'm showing you guys this is the way that the book kind of works for people that haven't worked through the book yet. Here's the questions over here, and then we ask things about the system. So the question here, really looking at this, and then like a tool like MPstat, which, by the way, I can make this just a little smaller so that it fits better, but then it's harder for you guys to read. I'll move it just down a little bit more, because then it'll fit better on there, but it'll be a little bit harder to read. Let's go to 3. Whoops, 3. There we go. That's good. So I run that, and MPstat's similar, every 1 second for 5 seconds, or every 1 second forever if I want. We can just sit here and watch this system. And the question over there on the right, question 5, says, when looking at this system usage, is this system under high load, and why would you think that? So if you're looking at this, and the far right number is idle, and it's red because it's red as it hits a higher threshold. If the system is 100% idle, what do you guys think that system's doing? Just twiddling its thumbs, right? Just going like this with its thumbs. It's not doing anything. This system is mostly, as far as this tool's concerned, which is looking at CPU usage, this system is chilling. This system's not doing anything. In fact, those little blips you see are probably mostly just my bash shell interacting and maybe some little tools or agents that are on there. Like this system is pretty much in chill mode, right? All right, so then we come down here a little bit, and then there's some questions. So we could also look at the system from a high level like this. We can say ps-ef, and that will tell me all the running processes on the system. It'll tell me who it is that kicked it off. The UID is the user ID, right? And the UID of root is the owning process of the system kernel, so it's who's in charge on the system. And then there's the process ID here, which associates to the process. And then the parent process ID. And it's kind of important to know when you've got a process ID and a parent process ID how they're related. So the parent process ID is always what forked or spawned the process ID, right? And we can kind of play around with this if we wanted to, but suffice it to say the system is almost all just using root. There's some other little user IDs doing some other little stuff, but we can actually figure that out. So we can clear the screen here real quick, and I can do ps-ef, which will show me everything again, and I can awk for just that first line. Now what awk's going to do, let me just do a ps-ef with a head so you can look at the data. What awk is going to do is it's going to treat these as columns, and they are going to be space delimited columns. So what it means to be a space delimited is, well, when you find a new space, that makes the next thing the next column. So this is column 1, 2, 3, 4, 5, 6, 7, and 8 in the system. If there's any spaces in here, there would be more, right? But and then there would be an uneven number, and then we would have to do something else if we wanted to pull some of that last information. But anyways, we just want the first column. So watch this. We're going to say PSEF, and we're going to awk. By the way, the command's right here if you need it. But we are going to print $1, and that is going to give us only the first column all the way down. We don't care about any of the other data. We've trashed it. We've thrown it out as we filtered it because it was, again, trying to come to standard out. We caught it and filtered and said, just give me that first column. Just want that first column. Then we're going to sort that data with the sort command. Sort will put it in alphabetical order. And then we are going to use unique-c to count it all. So if you were to do that command very quickly, you would be able to find out that this system's 109 of the processes are used by root. This system is doing hardly anything. Again, we looked at the load on the system a little bit. There's a whole bunch of other tools for load that we look at later. But we're looking at the system and we're seeing that it's mostly just chilling on root. There's not too much going on. Again, we can go back and look at some of the other things that we had, like MP stat, and we just see the system hanging out. Griffspad, I don't know how to say that. Hopefully this stuff's useful to you. Thanks for the follow. We are just going through the book a little bit. I haven't done this one in a while, where we just kind of do some system checking and ask ourselves questions and work through stuff. Fisherman, how's it going? I have something that's supposed to be popping up in chat soon. I don't know when it's going to pop up, and I don't know what it's going to look like when it does pop up, but I'm kind of curious when it does. So we'll keep an eye out for something popping up in chat later. But then we can do PIDstat. So PIDstat will show us what processes are running against the kernel in that 1 second, right as the slice happens on the system. Now, you might notice that sometimes nothing is happening for 1 second on a system. That's pretty regular. Surprise chat pop-ups. Yeah. Well, it's just going to tell people about the shop, and it's going to tell people, because there's something like where people can buy. I don't know exactly how it works, but it's kind of like they can gift to other people. I don't know why people would do that, but they could. So I signed up for it just to see what it would, what the process would look like, right? Because we got a little shop now, Fisherman. I don't know if you've seen that. We got a cool little shop going. You've been on work travel for like the last couple weeks, so I don't think you've seen any of that stuff. But and I just dropped the cap to my water. All right, so yeah. So here we go. We've got this. We can see that the system's not really doing anything. That's at a very high level when we first start. We're just looking, is this system chilling or is it actually doing work? And then we can dig down into what that work is and all this other stuff. But if you were to ask me to assess this server, I'd be like, this is just a server that somebody turned on. That's literally all it is. It's a lab box for us, right? We can do whatever we want with it. So we did all those things. We went down. We looked through that. And now I say these have different length. Why is there different length output here? Well, that's because sometimes a process is going across the CPU and sometimes there's not. So like for this 1 second right here, there was nothing happening in our system. Nothing was making a call or waiting on anything. Yeah, Colcus, you're waiting on your new nerd mug. There was, so Jared, my good buddy, who was the first one that found out about the site, he got his shirt today. So he's the first one to get an order fulfilled. But Colcus, you'll probably be next. You or Robodom, will probably be next. So, yep, drop my cap over there so I can't get my... So over here, we see that the system's, again, not doing too much, but we can see what it was doing. Container D is running. So this is running. I mean, I should be able to do something like Podman PS or Podman images and see if I have anything on this system, right? Getting in on the ground floor, yeah. Well, so Colcus, I know a few people that use that site, the same site that we're using. It's called Fourth Wall. And the people that I know that have used it have said, or have bought stuff from it, in the past, have all said that it's pretty good quality. Because I didn't just want to like do a bunch of crap stuff. That wouldn't be as good. So I have heard that it's pretty good. So I'm hoping that it's pretty good quality when you get it. So that's kind of yeah. That's the goal, right? I don't want to be selling you guys junk stuff that falls apart. It has to at least make it to the 1 year to satisfy its All right, I'm kidding. Anyways, next we may want to see more CPU and disk usage. So let's look at this. What is this command doing? And I know I shrunk my commands down a little bit, but the reason I did that was because some of the stuff was going a little bit too off the screen. So this one's doing something a little bit different. IOStat is doing something with the -XZ option that's kind of similar to what was happening before. So first, let's break down what IOStat is doing for a second. I'm going to make this a little bigger. IOStat by default does two things. IOStat-C will show you CPU information. So if I do like a -1 or just a 1, it'll be every 1 second for as long as it runs. And it will show us very similar information to that other stuff, the PID stat and the MP stat, where it's basically like, this system's chilling, guys. Alternately, we can do it with a -D, and that will do block devices. And block devices on this system are, in this case, only VDA1. So this system is not doing really any I/O. And that I/O is categorized by, right here, kilobytes read per second and kilobytes write per second. And then if there's any discards, if there's any... how many discards per second and how much discarded total. And that would mean that there were errors, guys. So errors would make discards. And then also the aggregate amount of read and write that had happened, not just the read and write per second. So this would continue to count up if we were doing something, right? Fisherman, it's actually funny. I don't know that. I've actually wondered that, like if it's going to be affected by any of that stuff, but I'm not actually sure. So we'll see what that looks like. We'll see what it looks like, Fisherman. I'm not 100% sure. By the way, if you guys start anything like I did with the IOStat-D1 or something like that, and it's just running on your screen, you can always hit Control-C and it'll just kill it. So that'll kill the process that's running. A lot of times, we will talk about this like as we go on today, but while true, do, uptime, sleep to, done. This is really bad computer science, what I just did. It's really bad computer science. I just made an infinite loop that's going to run until the system breaks or until the Earth falls into the sun. This is going to keep running. That's very bad practice. True will evaluate to true. It'll execute this block of code that's between do and done. It'll come back to the top. True will evaluate to true. It will drop into the loop. It will do what's between the do and the done, and this would happen forever. But this is really awesome for systems admins. I can do that, and I can look at the system for a bit. I can stop it. I can come in here and I don't need these tools with like IOStat, but I can do like an IOStat-C1, and I can just sit here and while I talk to you, see if my system's under load. Maybe I've got a bunch of my Java developers and they're about to spin up some Tomcat application and then hit it with like a load tool or a stress testing tool. And I can sit here and be like, yeah, go ahead and run it on the system. I'm tracking. I also probably have some other tools that would be good too, like Node Exporter, get all the information over into Prometheus so I can kind of see what's going on. But as we start out, this is a great place to, see what's going on over here. So anyways, okay. Yeah, Ranger Cam's down, John Doe. Somebody had put it, so on Twitch, people can hit the button and they can ask for Ranger Cam. But Ranger Cam's down. I will get it up here in a little bit. When this lab's done, we'll take a little break. I'll walk down and I'll get it working downstairs because I just haven't plugged it back in. So we'll get that. All right, we hit check, and this lab's done. Or that part's done. So now we're going to dig a little deeper into the networking stuff. Again, if you've just never seen a system, one of the things that I think is good to do is just touch the system, see the commands, kind of play the catch back and forth between you and the system. So we're going to do each command and see what's kind of going on. So first we're going to look at network usage and load on the system. So this is sar-n dev 1-5 or 1-5. And what will happen here is it's going to show us all the interfaces. So it's all the interfaces that the system sees. So there's a loopback, there's an ENP1S0, and there's a Docker 0. Now, all the information about those interfaces is aggregate right here. We can see the receive packets. Now, if you're new to engineering, RX is always receive. And your transmit packets, TX is always transmit. You will see that for your entire career. That will not change. That's been the standard for receive and transmit for over 60 years. Maybe, at least 60 years that I know of from my studies and from doing this stuff, right? You know, reading old papers and stuff. But receive and transmit always looks like that. And that's how many packets you're receiving and transmitting per second. Then this is your kilobytes and kilobytes per second in here and out here. Now, the reason I keep emphasizing that capitals are bytes and lowercases are b's is because when you talk to network engineers, your network engineers will almost exclusively talk about things in bytes. Almost. I can't think of an instance in my years of being a network engineer where I cared anything about. Did I say bytes? I should just quit. Bits. Network engineers only give a shit about bits. Sorry. You as a sysadmin will care about bytes. Like that's what's actually put on the system. Your system is going to read everything in bytes. But the network engineers care about bits. I don't know where I was going with that, guys. My brain was busted. But anyway, so if you see it like this, it's aggregated up to bytes, which is 1/8 of bits, right? So don't be talking past each other and wondering like, why the hell am I getting way different numbers than this person? Because the network tools are even going to look at most stuff different. All right. Then there's some stuff over here. How much is the interface utilized? This is very important. So if we're spinning up the interface and actually testing it, we should see this much higher, that kind of stuff. And then down here, we could very quickly see this system is not highly utilized, right? Then we come down here and we do that same thing, but now we look for TCP and error TCP packets. So now we see if there's any packets that are being run live here, and then if there's any retransmits or out of order transmits, because if we're talking TCP, right, Transmission Control Protocol, you must always receive the next packet in order, right? The next data in the stream must come in, or it has to be retransmitted. That's always true. And if something comes in out of order or you don't get everything within a window, you send a retransmit and everything gets retransmitted. So that's kind of a thing to know about it. But that right there, I believe, is that whole lab, right? But then we come over here to the right, and this is where I think the book adds value for people. I say, what user is running the majority of processes on the system? We saw that was the root user. It was like 119 of them, right? We can bang PS, and it'll give us the last command that we did that started with PS out of the history. So that's the command that we did to see that root was running, yeah, pretty much everything, right? Why might it matter? Well, because if we had a service account, and maybe I had like a service account called Service Tomcat, and that Service Tomcat account was responsible for kicking off Tomcat services for my developers on their developer boxes. If somebody said, Scott, is this machine that you're on, that you've never been on before right now, running the Tomcat service? I would look very quickly and go, well, I don't see Tomcat, right? Nope, I don't see Tomcat anywhere. That's just grep finding itself. I can get rid of that like this, right? Because the regex won't find itself. So, all right. So Tomcat's not running. Okay, but I also don't see the service Tomcat user running. Maybe I had a service Tomcat user that should have been running. I don't see that either. So. No, this system is not doing what you thought it was, but I've come to it, and the system itself, I can check it out and say, well, it's been up the time I expect it to have been up. You guys rebooted it almost 2 hours ago. It's been up for an hour and 42 minutes, so okay, good. You know, it's up. You know, df-h, it looks like it's got the disks it's supposed to. You know, the network doesn't seem to be throwing any errors. I can ping Google. Right? Which, if you can ping Google, there's all kinds of other things that are working in between there, right? I don't need to do the IP address and see if the IP addresses are there and IP route and make sure that the routing's good, because if I can get all the way out and all the way back, that's good, right? So there's kind of like these hierarchies to how we troubleshoot things, and we're not really going into troubleshooting now, but this is just touching the system and getting a lot of these commands into you. Right? And then we do a history and we look at all these things we did. If you did this lab, you hit most all of these commands that I'm doing right here. And then, yeah, it starts right here. I'm I went a little further on some of them and did some things a little bit differently. But for the most part, you can type any of these in. If you were doing this lab with me, which I'll link it again, you could do the exact same commands, the exact same things that I'm working on. All right. So then over here on the right, it says digging deeper. So I say read the manual for PS. So that looks like this. Right? Manual for PS. And I say, and see what other useful information you can see. Well, it tells me PS displays information about the selection of active processes. I come down and I read, and it goes, I can see what's going on. Here's some things that we didn't talk about in the lab. I showed you PS-EF, but there's PS-AUX or just AX that a lot of people like to use. This is very, very common. And if you know like old Unix admins and they come over to Linux, this is a very common one to see, PS-AUX. It shows you a lot of the same stuff. So let's look at this. This is PS-AUX, right here, versus PS-EF. They both give you all the information. They both show all the processes. Don't get that twisted. That's going to be the same either way, right? Like either way, we're about 122 processes on this box. They're not showing you different information about that, but they are giving you different information at the command line. So you might say, well, how would we use that? So let's go back to the man page real quick. I want to show you guys this. What I like to do sometimes is this right here. So PS-EO will show you every process still, but then O is the option to give me just some information about the process. So one that I like to do, I used to use this one a lot, PS-EO, lstart, PID, maybe CMD, right? And what this will do is, let's just do this one real quick. This will show me everything. It'll show me when it was started over on the left. So I can see everything over here on the left. Then it'll show me the process ID for it. And then it'll show me the command that actually was called to start it. So if I needed to go and look at how systemd resolve D is running, I can go actually look down in that folder and see the process, or see the software that was called. If it was given with some kind of different command line arguments, here we go, we would be able to know what those are right here. So there's a bunch of information that we can get about the system. All right, so there's that. All right, that's one. So I would spend time in the man pages, man PS, and then you can come down and go to options. So I did a / options, and then if I hit N, it'll move through all my options. It'll keep finding the next one until I get down here where here is how we select processes. You can grab just a process. I can keep hitting N, and I want to see the options that are available if they have them all listed somewhere. Here are the process state codes. So this is how you may find a process. It may be an uninterruptible sleep, meaning it's doing I/O. It could be idle kernel thread. It could be running or runnable, and those will show up in VMstat, right? It can be interruptible or sleep, waiting for an event to complete, so it can be interrupted. It can be stopped by a job control signal. There's a bunch of signals. You can go look those up if you man kill and see the different signals. And then we can check for paging and if it's dead or if it's defunct. You should not see many zombie processes. The most zombie processes I've seen probably in my career deal with when we're doing like storage area networking and we have specialized like modules loaded for like LNet or Luster, those type of things. That tends to be where I see zombies or have seen zombies in my career, but they can't exist on any system, right? And a zombie is a defunct process. You can't typically get rid of it without rebooting the box. So that's kind of a thing. And then here's my last little challenge. Go out on your favorite search browser and take an internet safari to read about a common release of Linux OS. Can you find what an LTS version of an OS is and what it means? So I might come over here and say, well, I've been using a lot of Rocky. So Rocky LTS, maybe support, right? What the heck is Rocky LTS? Well, I see that it's long-term support. And then I could probably go find Here's their long-term support, and let's see if I can see what it is. Okay, so how long-term support works. It's 5 years of major version support. Final major version, 8.10, 9.10, occurs 5 years after the major version release. The version receives minor maintenance updates for an additional 5 years. So that's good. I actually didn't know that that was a distinction there. So in those 10 years that LTS normally works, the first 5 years are major updates. They'll be major, and then the version receives minor maintenance updates for an additional 5 years. That's super useful, right? Then you get 18 months of minor version support, extended support for non-zero, even numbered releases. Life cycle of long-term support is 18 months past release expiration. So right here, we can look at the Rocky 8 and 9 release timelines. So if you were at a company and they were on Rocky, so this actually happened to our company recently. We have a bunch of systems that are on Rocky 9.3, and 9.3 is not being supported, so we have to take them up to 9.4 for the customer, right? And this is a thing that you need to understand. You need to look at these and know what these are, right? And then it tells you what the different colors read, what the different things are up here. But when we finally get up to 9.10, 9.10 will be supported all the way out to 2032. So your company doesn't have to plan. But if you're on Rocky 8, you're planning on getting off stuff here in the next 4 years for sure. But you do have to keep moving your versions up to be in supported versions. So this is a very important type page if you're going to be doing that. A lot of government systems I work with are on Rocky now instead of just straight rail like it always was, 10 years ago. All right. So that would be the answer to all the first labs there. All right. So the next lab that we're going to do, we're going to wait a minute before we go over there to that lab. I'm going to go get Ranger Cam working. We're going to go here, and let me pull this back up. And I'll turn this on so that we've got that running. And yeah, Ranger Cam's busted. I will go get that working. ISOBU, I don't know the deal with Alma Linux. I know of Alma Linux, and I've run it in the lab, but I've never run Alma Linux for any government customer or any customer ever. It's all been Rocky, and that's what Dell kind of recommends to people. Because my company heavily works with Dell on, Dell will sell stuff and then we'll come in and build for a customer. So Rocky also, the CIQ guys are the same ones that run Werewolf, and Werewolf's an awesome cluster management tool. Yeah, I don't know what Alma Linux's deal is as far as that goes, but I just know that I haven't seen them be used. So that's I wouldn't say that's good or bad. It's just is a thing. So all right, let me turn this off for a second. Let me pull up my hourglass, and I'm gonna say take a break. Normally I don't take a break this early, but and fix Ranger Cam. All right, so I'm gonna take a break and fix Ranger Cam. You guys take a break and walk around, stretch your legs, whatever. I'll be back. Let's see, is there our stuff? Yeah, there's our stuff. All right, we'll go in here in a minute. Sleepy Developer, thanks for the follow. I will be back. I'm gonna grab my water bottle cap as well. And yep, give me a few minutes. Go get Ranger Cam working. I might just grab a project right now too as I was walking. One of my buddies messaged me and asked if we could pull weather data from any zip code, and I know I can pull current weather data with a weather API that I use with NOAA, but I've never tried to pull historic stuff like to the hour or day, you know? So that might be something we will work on here in a little bit. Let's check on Ranger Cam. Is he up? He should be coming up. Let's see. What is this thing? This thing's something. There you go. There's Ranger Cam. Ranger Cam's back. Got it working. Wait, Crunk Master Cache. I learned about LTS randomly. We were trying to figure out which JDK version was. Yeah. There were tool sites that track scheduling across services. Yeah, Crunk. I deal with that a lot in a tooling that looks like this. So, like OFED. Oh, geez. So, like with OFED, if you're using some kind of like OFED here with like Linux, right? And then down here, I can sure. You would have to go. I'll pull this up for you guys like this. Mother effer. Fucking Chrome, man. Chrome is just fucking pissing me off. Anyways, it might look something like that. I'm gonna leave you guys might wonder why am I leaving the hourglass on. Well, because if somebody walked away for the break, we're gonna give them the full break. But I'm gonna talk a little bit while we go. Yeah, so let's say I had some version of like rel or something, right? So Crunk, let's say I had rel over here. Where's rel? Rel, yeah. And then I was on 9.5 and I was on x86. This would be the most recent version of this driver, and then I would have to validate that this works with the newest version of whatever GPFS that I'm going to most likely, depending on the OS and different stuff that I'm doing. But I'm probably using like in a big high performance compute cluster something like GPFS or Lustre, and then I have to validate that. And typically what I do is I'll get, let's say I'm on Rocky 9.4, that's a common one. So then I would download these and I would update them in my dev environment on 1 or 2 nodes, and I would build that process out. And then, yeah, you know what? So Crunk, I do use Firefox, but I use it on a different monitor that you guys can't see. And you might say, wait a minute, what kind of madman are you, Scott, that you have? I have, so I'm turning myself back on here. I have Chrome open for most of my messing around stuff and my college stuff that when I teach. Then I have Firefox on for where I go to college and other stuff like that. So I just don't have. I hate having to go into like a private or like a incognito to be able to log into something else. I don't want to do that. I want to be just logged in on my stuff. So I also do have Internet Explorer open somewhere, or Edge or whatever the hell they call it now too. So I use all the browsers on my system, but mainly because I don't want to cross authenticate. And if any of you guys have ever done anything with Microsoft, fucking any of their Microsoft like Office login stuff, it takes over the whole browser. So I just use different ones. Yeah, I have Firefox over on a different screen that you guys can't see, and then I have, you guys mostly see me use Chrome, and sometimes Edge pops up, but for the most part it's all Chrome that you guys see me use. But anyways, where I'm going with this is, yeah, there's support trackers and things that keep track of this stuff, but then a lot of times for me, I build my own matrices out. So I don't think I have it in a way that you guys can see. Hold on real quick. Let me see if I have this info over here in a way that's like okay for you guys to see. Hold on. Because I don't think I don't have a good example of it. Let me see. No, I don't have a good example. But I build my own matrices as I update servers, and then I write all my stuff. Then as I build my playbooks, all my Ansible playbooks are just tied to whatever things that I found. I get this ISO or tar or whatever. The OFED drivers, you have to build them for your OS anyways. So once you get them down, they build to the actual kernel and all that stuff. You need the kernel headers and all that kind of stuff. There's all kinds of stuff to this, but what I do typically is, well, I have to make a decision typically when I update it. This stuff, I either have to build it once and then push it to all my nodes as an RPM, but that increases a certain number of complexity, because if there's different types of systems that you have to build one for each type of the system. So if you have like a Franken cluster where it's been built up over time and it's all just different stuff, that may be slower. In fact, that's something that I don't like to do. I will just have it build and spend the 20 minutes per system because I'm doing it in parallel, and that ends up costing me less time too. ISOB, you said that ChatGPT. Yeah, ChatGPT can probably do a fair amount. I end up just slapping those things together because I have to do my own testing. I always have to validate for myself that my systems are stable before I move anything up into production. But anyways, I mean, I don't think anybody's going to want that, but if anybody needed that, here you go. So that was just us talking on break, right? Because we're going to come back from break. There's Ranger Cam. Look, Ranger is not in his bed. He was standing over here a little while ago, so when I was downstairs, he was standing on this bed over here. So I see his little shadow right there. So we'll give him a second, because I know he's gonna go lay down. He's old, so he just wants to lay down. All right, we'll get back to monitoring Ranger here in a little bit. Let's go back to Let's go back to our system here, and we will go to the next lab, which is checking kernels and packages. So more about figuring out what's going on in the system. If anybody wants to do this lab with me, here it is. It's over on the Twitch side, and here it is over on the YouTube side. It's free, right? It doesn't cost you nothing. All you got to do is go log in. Over on the right, this is from our book. This is the book that's up on LeanPub. And the labs, it literally just follows along with all of our labs and just asks you different questions, right? Just makes you think a little more about what's going on. So our task here is to learn Linux kernel commands and understand package management. Those are the two tasks. Our condition is given a bash prompt, complete in the allotted 60-minute time. That should be okay. And then the standard is to execute and understand commands, understand the command output for kernels and packages, right? And as soon as this thing's done, should be coming up here in a second, it says you are a new system administrator at a company. You've been tasked with finding out information about a set of servers that has little to no documentation on it. Well, I can assure you that's going to be common, right? So, check the kernel. Also, I'm trying to make that thing not see my head like that. But all right, check kernel and package info on the system. Echo the number of kernel versions that are stored on the system into root kernel, and then find the specific versions of software that the security team has been asking about. And then we want to know about SSH and the server and client. So we need to learn some information about the system. All right. So can we do that? That's the question. Can we do that on the system? Also, hold on. Did I fall into the lab in a weird way? Because it looks like my lab's not loading. All right. Should come back. I mean, sometimes when the system's a little busy, it takes a little while to come up. Okay, came right up. Yeah, sometimes it's just weird. Hold on one second. I gotta text somebody back. I'm streaming, but could probably get a CSV out tonight. Hold on, I need to ask granularity of I'm going to tell them every 6 hours. So every 6 hours, the critical weather information runs through NOAA. That's like a common standard. Every 6 hours, they produce this weather product. 6 hours is the normal. historical. Okay, anyways, I'll let my buddy get back to me. He's one of my statistician's buddies, and he does economics and stuff, so he probably needs the info for something. All right. So you're new sysadmin at a company. You've been tasked with finding out information about a set of servers that has little or no documentation on it. So we want to check kernel and package info on a system. We want to echo the number of kernel versions are stored. Oh, I read this already. Okay, so you guys can read that too, right? Here's our solution. If we want to check the kernel information, uname -a, and that'll tell us everything about the kernel. I like to see just a uname -r, and that's also something that can be executed against. So you could put that like in a script and look that we're at least on kernel version 6 something, right? So that we ensure that we are on the right kernel version for whatever software we're doing, that kind of stuff. It can become important. We can check old versions of the kernel that are here. So ls in boot, everything in there that's VM is a kernel. So there's VM Linux. Here's the generic kernel that was called when the system started. And then there's these two other ones. And I look at them and I go, that's interesting that they're this other color. By the way, that color is not built into the shell, right? We can unalias ls, and that will no longer happen, right? There's an alias that's applied in our systems that actually causes that to happen, right? By the way, if you need it back, if you did that with me and you're like, oh shit, Scott just broke everything. For me, it would be root.bashrc. Should bring it back. Yeah, there we go. Because that resources the bashrc, which resources the etc bashrc, and then that should find it, right? I can show you guys that whole process right now, but that's kind of going down a rabbit hole that we talk about in other labs and stuff. So let's not worry about that too much right now, but just suffice it to say that's the magic that brings it back, right? All right, anyways, but that's not a good enough answer for me because I see 3 things, but I just told everybody it was 1. Well, the answer lies in this -l, which is the long listing of the system. And the long listing of the system will show us that those 2 things, that weird color that they get, is because the system is showing us that they're symbolic links. What's a symbolic link? Well, it means that it's a link over to something else. And this is a link over to, well, they're both actually links to that one real file. So there's only one file, like I said. It's just these other 2 things are just linked over there. That's all those are. We can unlink them and it wouldn't affect the system in any way functionally. Well, it may affect the way that boot could be called with grub, but it doesn't matter because everything points back here. You wouldn't want to just remove those willy-nilly. Let me make sure I'm saying that correctly. Because if you were to remove them, something might reference them and then that would break. But what I'm telling you is them by themselves are not doing anything but pointing over to this other system. All right. Anyways, yeah, don't remove them and then wonder why the system busted. But truly speaking, we only have 1 kernel on this box. We do not have a backup kernel, and that is not operationally ready in a systems world. We want to always have at least 1 kernel to fall back on. And you might say, well, Scott, what if we test it in dev for 2 weeks and then we run up and then we go to prod? Should I still keep an old one in prod? Yes. I have had systems that have not manifest their actual problems until we get under a production workload, and then we see that the churn, and then we see that the things that are happening are not happening in a way that should work, and we have to back the whole thing out. So that's definitely yeah. Oh shoot. 2 is 1, none is 1. Yeah. So over here, we can see all the packages that are on the system. So dpackage-l will just list them all. And if we do this with a word count -l, we will not have to count them up ourselves. Like we can count these, right? I can do a dpkg-l, and that's going to drop me in this interactive thing, and I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, but I'm not going to do that. And I can also say page down, but I'm going to get my fingers tired after a while, getting down to 814. What I could do instead is let the system count them for me, 814. And then you take 5 off because the top were all headers, so about 809. But 814, 809, that's within about a rounding error. You know, that's not that big of a deal in the systems world. What is a big deal is somebody might ask you, what's the version of SSH you're using? dpkg-l and then maybe grep for SSH. And here's all the SSH information, all the packages that have the word SSH in them on our system. I'm going to make this a little smaller again, just so that they all fit a little nicer, even a little smaller, and they fit a little better there, so you guys can just see that here's the OpenSSH client and OpenSSH server. Those are probably the two most important things. Those are probably the things you are going to interact with as a Linux systems administrator more than any other tool on a system. The way that the system reaches out is the client, and the way that the system accepts connections back in is the server. Those two things probably will haunt your nightmare eventually. They are probably two of the things that you're going to run into the most as far as like just system level stuff, right? So I say over here, what version of the kernel are you on? uname-r. About how many kernels do you have? 1. What are the other output? Why are they not considered kernels? Well, because they just point to the kernel, right? That's all it is. It would be like if I was holding a box and two of you had boxes, and when you reached in your box, it was just like over to my box. There's only one actual box holding anything, right? And then I said approximately how many packages do you have on the system? About 814, 809, 814, somewhere in there. I say, what version of the SSH client are you running? And why might this be important to know? Well, because all vulnerabilities, every CVSS score that's ever been registered with NIST, every score that's ever been out, every piece of software that's ever been vulnerable, they've always reported on the version of the software with which the vulnerability applies. Because then we know if we can get up past that 196 to 197, that we're on a newer version that vulnerability doesn't apply to anymore, and we're past whatever that danger is. We're past that vulnerability, meaning we hope that there's no exploit for it, right? And then the threat is now, well, in this case, the threat is removed as opposed to being like mitigated, or we have to do some kind of other thing to try to protect our system, right? So, we've got a client called OpenSSH client and OpenSSH server. And then over here on digging deeper, I ask you guys questions that you can dig in a little more. Let's start talking about backport patch. For sure. Yeah, I was talking one day on here, I was saying how, every time somebody patches something, and especially you actually see this happen. If you guys work with Red Hat long enough, you'll actually see that they don't like the operating system that's their current supported one has all all their most talented best engineers, and I hate to say it like this, but it's true. And then their older stuff that's like RHEL 7 right now, that's in extended life support, they don't have their number 1 and number 2 engineers on that. There's some other engineers. Anyways, where I'm going with that is patches come out that reintroduce vulnerabilities that have been fixed in systems for 10 plus years. And you go, oh gosh, they got the new guys on this one, because something will get opened up. Every time you patch a system, it's like you're sewing a not big enough patch on something, and something else becomes vulnerable again. It happens all the time. It literally happens all the time. In fact, one of the things that happen, if you go watch attacks and flows and systems, some people will patch brand new systems and put them out there in their DMZ for people to hit, because they want to see the same thing that the people that are attacking the new patch systems want to see. Where's the vulnerabilities? I actually know people that just sit there. It's not really honeypotting, because they're actually allowing the systems to just sit out there and be attacked, but because they want to see what the techniques are that are being used against the system. I have a few friends that's what they run. They run some of those environments. So also, I might have just pulled extra duty. I might have just volunteered to do some work. I'll get it worked on here in a little bit. But if anybody wants a fun little project, go look at NOAA. Other data, right? So NOAA has massive amounts of data sets that are out there that are available, and one of my friends needs to query via zip code from some of these. So I may have to. I'm gonna have to pull some API stuff here a little later, because I have stuff that pulls current weather data for different zip codes, right? And yeah, he needs zip codes, not area codes. Sorry. And And I can do that, but I've never tried to pull historical data, like for every hour of a day or something like that. And I'm pretty sure I know why he needs it for energy stuff, but I think I can get that for him. I can get him the code for that and get him the API stuff. So yeah, Crunk. I'm a big fan of a lot of that stuff. We actually used to run a little project here. We didn't get super into it, but we were doing like a little thing that we were calling dungeoning, where we were just letting everything connect, and then we were just watching what the payloads were in like inert systems, and it was just kind of funny to us. We didn't really do it for any serious reason though. But we'll mess with Noah here a little later because we're doing Linux stuff for now. But some of you guys know I'm a data guy too, so I will mess with that here in a little bit. All right, so if you guys did this with me, you just did the whole lab right there. But let's go look at the digging deeper. So the digging deeper is that stuff that you can go spend more time with if you wanted. And it says here, in the enterprise, you may find yourself having to put in tickets for hardware or software implementation with different vendors. The first questions will always be asked: what are the OS and kernel versions of the system? What are the software versions you're using? Understanding this will greatly help you supporting enterprise Linux. Yeah, so if I'm having a problem, like if I'm doing, this user is, I try to SSH to myself, and I'm getting some kind of problem, and then I connect, so then I go back out, and then I go to connect, and I do like a -VVV, so I see a verbose connection back to myself here. And then now I go and I look at this, and I'm just having some kind of problem, like something's not working the way that I expect. Well, the things that, so if my company's paying for support, right? And by the way, this is a big question, because if you're doing enterprise support, you probably are not in the business of writing your own operating systems. Therefore, you're probably paying Red Hat or CIQ or Ubuntu. Ubuntu is canonical, right? You're paying somebody to support that system. And that's awesome, because now you have engineers you can ask, and you have tickets that you can put in, and you don't have to go about writing your own operating systems. But that being said, if and some of you will in your career, you guys are going to have quite a bit of ticket activity when you first start out. One of the things you're going to hate is when somebody says something like, well, the system's acting funny. And you're like, well, what is it doing? Telling jokes? This isn't that big of a deal. So we want to help them help us. Yeah, that's a good way to put it, right? So the things I will always, if I'm putting in a ticket, I've already read through all their stuff. Trust me, like 1 and 2 level support, the first 2 levels of support where we're just reading the knowledge bases, I promise you, I do not want to send I never want to send a ticket in. I think a lot of engineers are like this. If I'm sending in a ticket, trust me, I've already scoured your fucking pages. 100%. That being said, I don't want to get asked this stuff. This isn't a cockiness thing. This is just I know this is the first thing. It would be like if I called you and wanted to order pizza, and then I was surprised that the first thing you asked me was, do I want to pick it up or carry it out? Like, isn't that the first thing they're always going to ask you? And then when I say pick up or carry out, like drive, I don't know, delivery. What if I said delivery and then they're like, what's your address? And I'm like, why would you want to know my address? Well, they'd be like, what the fuck is wrong with this guy? But that's the same thing with support. If you're going to put in a ticket, you got to tell them the system. They don't know your system. They don't know how you configured these 1,000 boxes. So yeah, I would 100% of the time get, but also this is what we need to know about our own systems, because if you have a system that's on 2404, your stuff you're going to look up is different than an Ubuntu 2004. Some of you guys were maybe around earlier this week. We were doing a lab, and I go, what the hell? Because I was so used to them being on 20.04, and they updated it. And then I went and looked in the Slack, and I was like, oh, hell, they did say they were updating it. They even posted it on LinkedIn. And I missed it because they jumped from 20.04 to 24.04, right? And I was just like, oh, geez, I didn't even... Anyway, so I said, go out to your favorite search browser and take an Internet Safari to read about what types of Linux kernels are available and which ones map with common OSs that you've used. Why might this be useful to you? All right. So I might just go out and say, Maybe that same thing, Rocky, Linux, LTS, and maybe down in here, maybe in their long-term support guide, it might not show it here, but sometimes they do. They'll actually show the kernel versions or the major or minor kernel versions that are applied. They don't show it here, but I may want to keep that information, right? I may want to know, like my Rocky 9.4 box over here. This is the home lab, right? This is the same labs any of you guys can get in if you want to do our Linux admin course or our Linux security engineering course. So here's this, and then uname -r. The Rocky 9.5 is still on the Linux 5 kernel, but Ubuntu 24 is up on this other one. All right. Yeah, I'm gonna write some. I don't know if anybody's gonna be around later when I get off, but I'll probably be down in the Discord writing some API calls for this NOAA data that I got to pull now. So if anybody wants to see that or mess with that with me, or if anybody wants to just go do it for me, because I know some of you guys are coders and some of you guys like doing that stuff. I just need hourly data by zip code, and I'm pretty sure there's something already written, but I can write it if not. I know. I could at least do, even if I needed to translate zip code into lat long, I can still do those queries. But I'll get that. I use Python. Look, I'm like a simple guy. I use Python for everything. That's the one I know best that's supported. I can also do most things in Perl, but Perl's not really. I mean, like Perl doesn't have a lot of the support, and also nobody's writing in Perl anymore. So like I still do some sysadmin stuff in Perl, but not stuff that I show people. Like when I say, I'll show anybody down in the Discord anything you guys want as far as system stuff, but when I'm doing professional work, most everything I do is either Bash, Ansible, or Python. So, but I won't use Ansible for this because, well, I could, but I probably won't. Python will probably be my thing of choice. All right, so let's go to the next lab. We did that, and look, we've gotten 2 labs down so far. We're knocking stuff out. We're going through. This is the book, right? So if you guys have never seen the book, this is the book. It's over on LeanPub. And the next labs, the labs are all free on Killer Coda, is going to be disk and mount point. So we're going to go and do some disk and mount point stuff. So disk and mount point information looks like this. You're a new system admin at a company. You've been tasked with finding out information about a set of servers. Now, some of you guys might go, Scott, you got to be like, you got to be exaggerating. That's not going to be that common, right? It's not going to be that common that we're going to be sysadmins at a company and there's not going to be any documentation, right? That's not really a thing, is it? And then all the admins just laugh and laugh and laugh. And I go, hold on, guys. They don't know. Hold on. But then once you get in, you'll get the joke too. Because, yeah, it is going to be that bad. And you go, but surely not, I'm going to AWS. Or surely not, I'm going to... And the AWS guys are in the back laughing even harder. Because, like, I'm telling you guys, for all the stuff that's awesome, there's always a few little dirty corners that are just, like a little dev environment that grew up and it became a proof of concept, and then it became something that was running in prod. And, guys, you would not believe how much that happens in real government systems. In government systems, I think most of you would believe. But even in like big corporations that you're like, there's no way it happens. Something just slides in, and it's more convenient to just use it as is than to build it again. And then next thing you know, you've got to just, you're standing there with all your services and something's standing there like that. Remember that little guy they wouldn't let hang out with the Spartans because he wasn't good looking enough? Didn't have the right abs or whatever, so they're like, go over there and go hang out at the pass, and then he betrayed him because he was an asshole. I think isn't 300 like, I think that movie 300 is like over 10 years old now, so maybe that's not like a pop culture reference anymore. That would make sense to some of you guys, but anyways, all right. So let's go do this. Let's check physical disk information. Let's look at the number of disks we have, because that's very important, and then let's look at the number of partitions on those disks. and then we'll echo them in. And actually, it's funny. I think this lab might not be right anymore. So let's go look. All the disks that are there. Oh, it's not right anymore. My lab is no longer correct. There are now 1, 2, 3, 4. So I'm going to have to fix this lab. There are now 4 partitions and 1 disk. So there's 1 dev VDA with 4 partitions. So we do an LSBLK, and we can see that. And then we do a block ID, and we can also see some of that same information. Yeah, Crunk, also, I don't know if you know, but there's a little passage that was right at the end of Mary Shelley's Frankenstein that, as Frankenstein's monster was floating away on the iceberg, he yelled back and he said, I know you guys are going to just call me Frankenstein, and that's okay. You don't have to call me Frankenstein's monster. It's okay that you're just going to call me Frankenstein. And then that's the very last. Have you guys ever seen, does anybody here know what joke I'm talking about here? Hold on. This has actually been written into books. It's super funny to me too. This has actually been written into books as like a joke, but it's also, hold on. It's right here. This is like this famous. This is so like just funny to me. Open image in new tab here. All right, and then scroll in, and it's as he drifted away. I could just make out his final words. It's okay if you just call me Frankenstein instead of Frankenstein's monster. I don't really mind. The end. And then that solves everybody's problem, right? Because people that have read the book know he's Frankenstein's monster, not Frankenstein, right? And then people argue all the time on the internet. But that one little thing solves it all for everybody. I don't care. I don't care what you call me. I don't mind. I love that. I want to get, so my wife's got like 2 copies of the book. One's like a really nice, because we have like kind of like nicer versions of the books, and then we have like just other copies, and I kind of want to write that at the end of it because I've shown her this and she knows the joke, but I want to slide it. I wouldn't do it on her nice version because like her nice book is like part of a collection. But anyways, that's a joke if you guys have never seen that for Frankenstein's monster. All right. So this is no longer correct. I actually need to go fix. Let me go fix the lab. I'll show you guys. The lab is here, and hold on. Did I fix something else too? No. Here, the step 1 text is this should be now 4, and the verification should now be 4, and Control S, and then we will say fixed number of partitions in lab. And then we'll commit it and oops. Save all and commit all. Yeah, that was my bad. I should have said, you always save them before you commit them. That's my bad. I was just going through them quick. Boom. All right, let's get this out of here. That's going to update the lab. So in like about 5 minutes, we'll check the lab again, but then this will be right. So anyways, we'll drop these in for now, and then we'll be able to say check, and we'll go forward. Now we're going to check the file system type and mount points. We're going to echo the file system types into system. So there's a few ways that I can find the file system types. There's a block ID, and we can see right here that we're using ext4. I could also, if I knew that it was VDA1, I could do the mount command, which will show me all the things that are mounted on the system. And I could grep for like VDA1, and then out of there, I would see that I've mounted VDA1 on /, which is the root of this file system, as ext4. So I'm on an ext4 file system. That would be a way to find out. That's probably the main, these are probably the main ways that I would find that. So here's that. The other way is how was it mounted? So cat etc fs tab shows that we mounted it as an ext4, so that's also how it was mounted right here. And it was found by its label cloud img root fs, which the label is right here, which maps back to dev VDA1. Dev VDA1 maps to what is mounted on root of the file system is ext4. It's all chutes and ladders, guys. Everything points to something else. Everything slides and works correctly all the different ways that it works. So that's it. Boom. So here's all the commands that we just did. right? And then we throw everything in there. I have a few other things I show where like we go look for the label and we see that cloud img root fs actually mounts back to dev VDA1. That's all that shows right there. And then you can cat etcfs tab in there, and if we check, it should be successful. And then we'll check disk size and usage. So how much of the disk are we actually using? We do a df-h. That's probably the best command for this. Will show us what's mounted on the file system and how used it is. And on dev VDA1, we have 14 gigs available. It's very important to know that up front, because then we will do, we'll just throw that in there too. Does it say 14 gigs? I might have to go fix this real quick too. Hold on. I might have this one other thing now. Might be busted down in step 3. What's the verification? Stat root big file. Okay. It'll look for that. Okay, so whatever it is, it's right. Okay. I just want to make sure my validation was correct. All right. So we come down here and it says now we had 14 gigs free. Let's make a big giant file. So this is how you would make a 3 gig file on your system. You would use the disk duplicator command. The in file would be dev0. You're just pulling zeros off the processor. Out file would be root big file. Your block size would be 1 meg, which is 1024K, and then the count would be 3000. That would be about a 3 gig file. And if we do a df-h on root of the file system, we would see that instead of having 14 gigs, we now only have 11 gigs. So we just spent 3 gigs of space. We filled up a balloon, as it were, and just dropped it in there, and now there's not a lot of space. So if we go and look at that file, it's also about 3 gigs, almost exactly. When we do an ls-lh, that's a cool little command that'll show you a long listing, but in human readable format. If you don't do the H, you'll get the same output. It'll just maybe not be as easy to read, right? And then I say, well, what about this df-i? df-i will show us how many inodes we have free. And we have on the system about 2.3 million inodes that we can use. Those are memory addressable locations in the system, right? So we're going to use up 1,000 of them. So we had this many. 10,000. We made 10,000. So now instead of having 2.36 million, we have 2.35 million. We used up 10,000 of them right there. If you run out of inodes and you still have disk space, you still cannot write anything else to that file system. So this is actually a question that like people like to ask Linux administrators when they come. I've actually heard a lot of people ask this question over the years. What happens if you fill up the inodes? And people are like, I don't even know what an inode is. The inode is the memory location, right? It's the thing that finds where the memory is on disk. It's how many addressable locations you have available to your file system. And you can fill them up. We could fill them up right now. It'd take a while, but we could do it. And then this operating system would no longer be able to write, and operating system functions would cease. It would not work properly anymore because there's nowhere else to put things, even though there's all kinds of space out on the shelves, as it were, but there'd be no way to label and put things on the shelves anymore. So you would break stuff. I tell you guys, I've run into this twice professionally in my career. Both times were with GPFS. Both times were very manageable, and we never saw them again after we implemented the right things in place to track the inodes, because the inodes were filling up in our high-performance compute cluster before other things, because the workloads that our researchers were doing were very many small JPEG files, and they were put, for every job that they ran, they were putting like millions of these tiny little JPEGs out there that weren't using hardly any space, but they were still taking up memory locations. So that's something that kind of happens. So anyways, all right. ZFS has dynamic inode allocation. Nice. Yeah. To bread but it has to trade off, right? It has to trade off and use some of its space, because that's what GPFS does. You have to take a little bit of the space of the file system to give a bigger inode allocation table. That's what you end up having to do over there. So, because there's always a trade-off. There's always a trade-off. You can address more memory, but then you have to give up some space, or you have to hold more in RAM, or you have to do something to get more, and then it's always a trade-off. So you have to think about how you want to use your system, right? Okay. So over here we hit check, and it says, look at you doing Linux. You looked at the disk space and usage. So Did I need to fix? Yeah, there was nothing else to fix in this one, but now I got to go back and check. I got to check that it's good now. So give me a second. I'm kind of a fanatical person. Over here, we'll look at the commands here in a second, or we'll read this over here. You guys can read that on the right. I'm going to do the lab again real quick just to see that my stuff is good now. So that, and then check, validate. Okay, good. So I checked that we validated against 4 partitions because there's 4 partitions now. And also it says right here, 4 partitions. Yep, so there's 4 partitions. And that makes sense because that's what we saw in the lab. All right, so I just updated the lab in real time. And I said, of these disk commands, what seems to show you the most important information and why? So here's lsblk. And you can also, lsblk has, I think, like a dash, what are the other commands? Some of you guys had some pretty good versions of this you like to look at. Was it dash capital T? That one's okay. I think that's the default. Some of you guys had some other ones you guys like looking at that I thought were kind of cool. Not perms. Oh, dash P might be it. Yeah, so that's kind of cool because then it shows the path as well. And then I think there was one that gave, was it the F that gave a file system? Yeah. I think it's the dash F that some of you guys were using. Maybe PF. And, you know, there's different ways to look at this stuff, guys. This may be more useful to you. Yeah, that's not a bad looking one. Tells me that how my system is being used and then the usage and the available. Yeah, that's fine. I don't mind the F at all. It also gives me a file system information. So lsblk-f may be one of the more useful versions of this if you've never seen it. So there you go. All right. So over here, what is the file system? We saw that it was ext4. What are the types of names that are given to partitions? So VDA is the first disk on the system. VDB would be the second disk if we had it. And then VDA1 is the first partition of the first disk. 14 is the 14th partition. Presumably on this system it's the second. And then VDA 15 and 16 are the third and fourth partition, you know, respectively. So there are 4 partitions total on this system. It says, why is it important to know about the size of the partition as well as the inode? Because either of them can fill up. That's a huge thing to understand. And how do you check each of them? df-h and df-i. Now, I might have showed you guys, I didn't actually do this. df by itself works fine, but I don't like the output. I've never in all my career looked at that for real. I've only ever used that to show people just do a df-h. I've never seen anybody that wanted it like that, and I've never seen it used like that. So something to think about. All right, digging deeper. I said if you look up the CIS benchmarks for RHEL 8, you'll notice that one of the first tasks for hardening a system is setting up different partitions. Why might partitioning a system be so important to security, and why might you not want to partition a system like that in the industry? So, very similar question to this would be, if you were to open this up, these are the DISA STIGs, right? These are what we're doing in our security course. These are just generic ones that I've been doing to mess around. But if you go to the DISA STIGs, and I'm on RHEL 9, so we'll just go RHEL 9, and I'll come right here to no exec, right? And we'll go to overall, and then no exec. And here's all the times it wants me to put no exec on temp or varlog or varlog audit because they're on their own partitions. But maybe var temp and varlog audit and varlog and temp don't always need to be on their own partitions. And then the question here for you to think about is, why might they not need to be on their own partitions? Well, in my home lab environment, I don't do that, right? So in my home lab, where we run these systems, and then we look at the systems that are there, and then we maybe just look at what's there. We don't have all those var and var temp and all those different file systems mounted. And you might say, well, why don't you follow best practice? Well, because I understand that the reason that there's a no exec in there is to prevent things from being put in there and then executed by processes that shouldn't, right? Well, but partitioning like that, the base reason that we partition stuff like that is to set a smaller blast radius if something happens to our partitions. Well, this box right here, if I reboot him, if I reboot Rocky 5, when he comes back up, he's a stateless node. He comes back up as a base system again. And like I literally don't care about that box one bit. He'll just come up as a clean system again. The reason that's important to know or understand is I can then say in my STIG defense, as I'm putting this together for my clients or my customers or whoever I'm doing STIG reports for, is I can say, well, that's not actually a requirement, or for us, we find that as something that's not needed because we are mitigating it with these other factors, and that's just something that's built for a stateful node, and we're using a stateless node. And that would be part of my defense of it, and then I would go and call it either not a finding, or I would leave it open and let the security teams put it as not a finding because they agree with me, or we could argue about it. But at the end of the day, the real thing we care about in most of these things is getting a high enough score, right? Having our score high enough that it passes whatever bar we need. That's one part of it. The other part is actually securing your systems, which is why I like to be able to defend why I do or don't protect certain parts of the system, right? That kind of stuff. It's easier to do that if you understand what the system's doing too, by the way. I guess. I mean, I would think that goes maybe without saying, but it doesn't always go without saying. So all right. That's gonna boot, and then that's that lab. That's lab 3. Then we come down here to lab 4 and we do some networking stuff. So I'll let that, we actually don't even need to leave that. We'll just come back to that later. That's just in the home lab. That system's fine. Sinbleed said, can you ask a crypto question? You can. I don't do, it depends what type of crypto you're talking about. If you're talking like cryptography of a system, I'm probably marginally better than average. But I'm nowhere near like some of the cryptographers I know. If you're asking like a cryptocurrency thing, I don't do anything with it. So I can't tell you. I mean, I know how blockchain works. I understand the technology, but I don't do anything with it. So I know how blockchain works with like file systems so that we keep everything consistent and stuff. But other than that, I don't know much about what anybody would probably want for crypto. But you can ask it. I mean, I'll answer it if I know it, but I claim no great expertise in that space. So I claim no great expertise in most spaces. I've just been doing this stuff for a long time. So, new sysadmin at a company. You've been tasked with finding a set of information about a set of servers with no documentation. Again, that's a real type of thing. So let's check our network info. Let's put the name of our network interface in a file called root interface. Let's put the IP address of our network interface into a file called root primary IP. And then let's write the default route that we have out to a file called default route. Okay, so we're going to see if all these things work like we expect. We're going to do IP adder, and it's going to show us 3 things. We've got our loopback address that's always present in the TCP IP network. We've got ENP1S0. That is likely going to be our actual network device, but let's see. How's it going, Robodom? We're just hanging out, working on stuff. I'm actually really surprised. I thought that there was a message that was going to be coming up over here, but I haven't seen it yet, Robodom. Apparently, I mean, maybe the system's asleep. Maybe it's not set up all the way. Let me go see if it's going to work or not. Hold on. Whoops, that is not what I meant to do. Jeez. Hold on a second here, guys. That was 100% in all the world not the way I meant to do any of that. Give me a second here. Let me go and pull up. It says that's connected. Hold on.
Want to allow your viewers to give...
Oh yeah, so that's not... Okay, well, I don't know. I don't know why that's not working, but I will play with that later, I guess. All right. Also, shit, everything like jumped around on my screen. Hold on a second, guys. Literally everything jumped everywhere. Did not mean to do that. All right, all right, all right. Anyways, so I'm back here. Make sure everything else is what I want. Okay. Although this thing did not back up like I wanted. All right, there we go. All right. So, Isobu, hold on. Let me read what your question is. I've heard cold wallets are sometimes interface through vulnerable web apps, so you have to be careful about authorizing. Yeah, for sure. No, Robodom, I turned those off, but there's another message that should be popping up from the Do All the Linux site. Hold on. So Isobu said, for how long do you want the hourly data for the weather? Isobu, I don't know exactly how far back he wants it, but I think for the last 2 years is what he's looking for. So if anybody wants to pull that data, that I am going to be doing that here in a little bit on offline here. Sinbleed, he said, so I have a kernel module. Kernel internally has keyring, which manages search to verify signing of kernel modules. What I want to have nodes and system from master controller. I'm writing a security zero trust framework. First chain of verification between controller and each node. Second chain of verification. Generated module. SLM will be using. Don't need block ciphers. This is huge, but I need to write a crypto security framework. Yeah, so Sinbleed, that is something that I could maybe help with. But thankfully, it's not. I was like, hopefully, it's not a question about crypto. I definitely have done. I haven't done that at the kernel level, but I've done some stuff where we pass information around and ensure that the information updates and hasn't changed between the nodes. But that's about as far as I've gone with any of that. And getting quorum of systems and those kind of things. That's about all I've done. And mostly I just implement it within tools that are already built. So I don't do a lot of building of that. But that is, I mean, that's interesting. Are you in the middle of that? I don't know if you mind dropping any of that in the Discord, but that's something that there's a few of us that would definitely chew on that if you were, especially if you're doing that open source. There's a few of us that would definitely work on that. I wonder if I can get some of these things made. Like this is, I use these little things like under my wrist, but mine is just a map of the world. I would definitely have one with Prolog Linux on it if it had it. But anyways, yeah, Sinbleed, I don't have any good expertise in that area, unfortunately. Not any more than anybody else you might find. And then Hayes, you started a huge migration today. Yeah, yep. Migrations are always fun. Whenever I talk about moving data, I always talk about the free cell problem. Anybody here ever played free cell? You got the 4 free cells and then you can move. And then when you get stuck, you can't move any more data without like losing data. And I always talk about that when we move systems, like our low free cell problem. So okay. GRPC, yeah. Sinbleed, do you know who might know some stuff about what you are asking about? And I only say this because they probably know the most that pops in the channels. If you ever run into Taniwa, they develop a lot of stuff for Tani's in channel pretty much on the weekends for the most part, but they travel a lot with SANS and they train people and they have a few papers on SANS stuff with Zero Trust. They were the one that I've told you guys that wrote the Spiffy Turtles All the Way Down, the Zero Trust model. They were one of the authors for that. So anyways, let's do this networking one. Let's keep going on this. I always show you guys this, but I'm going to show you guys a way that I like looking at this stuff now. I do IP-BR ADDR. Look at that. That's like super small and clean. And that's the way that I like to show, like if I'm just talking to somebody and showing them all the systems, all the networking on their system. Here you go. So if I knew nothing else about this, I would probably know that this is the system that is, this is what's connected out, because LO is the loopback and Docker is almost always internal. So if I do IP route, it'll actually validate that for me that, yeah, only traffic like that's going internal. And then traffic to my local network is going to ENP1S0. And my default, this is really the key, my default goes out ENP1S0 as well. So that's definitely my default interface. So, okay, so let's go throw that information into all we're doing now is throwing that information over into we throw that over into a file, and then we can ping 3 times the default. This is our gateway right here, 172.30.1.1. We know that's our gateway because if we do an IPR, we'll see it. There's our default route is here. So if my system doesn't know what to do with it inside of its routing table, if it didn't have a default route, it would drop it on the floor and not care about it ever again. Because it has a default route, if it doesn't know what to do with something, it shoots it out like a little hot potato over there, right? So we also have another command. We can do IPR or IP route, or the route command will also give you, route is not on all systems. You can put route on an Ubuntu box with apt install net tools if you want to, but route is on, by default, route is on most of your Rocky and Red Hat Enterprise Linux boxes. So anyways, we'll hit this and it'll say validation successful. We'll move forward. Check open ports on the system. Can you find SSHD and containerd listening on our system? If we can, we'll write yes into root ports. So we'll do ss-ntulp and we'll see a whole bunch of stuff. And we'll look just for those two. And there's containerd and there's SSHD. So we did our ss-ntulp. We piped that through a filter, a search function with a -E, which says extend the functionality. It used to be egrep, but now it's just grep-e. And we said anything with SSHD or, that's the or right there, pipe, containerd. So SSHD or containerd, and we found them both on our system. So we're going to write the word yes into root ports so the lab lets us go forward. And then another way to look at this would be to use lsof-i, and we'll see that systemd started SSHD, and SSHD is holding open port 22, which is SSH on our system. So that's cool. We could also try to connect to it and see the header information that, yes, our system is sharing out on port 22 right here. And we're connecting to ourselves. 127.0.0.1 is always home in a IPv4 network. And we're doing a timeout 3 so that netcat only has 3 seconds to run, and then it drops us out of the shell. Sometimes you can get away with nc-vz 127.0.0.122, but not always. So there it worked, but you just don't know that it's always going to work. So don't worry about that. We can also do systemctl status for containerd and see that it's running. Then we can stop it. So I'll hit Q and I'll stop containerd. Oops. Stop containerd. And then I'll go run it again, and I do not see containerd running on my system. Right? So I could stop it. I did all those things. And then now we're going to check some traffic in our system. We're going to look at the throughput of the interfaces, and we're going to create a little file called root-ubuntu.pcap, which is a specific type of traffic file that we read with a tool called Wireshark. You can read it on that system, or you can pull it out and give it to like your storage or your network team or whatever. But a lot of times we're the only ones that can run it because we're the root, on the system. So anyways, I'll come down here and I might do a command like ifstat, and every 2 seconds for 10 seconds, I want to see the interface statistics of both ENP1S0, which I know is my primary interface, and Docker0 to see if I had any Docker traffic happening. I do not see any of that on my system. So the system's mostly chilling. Just chilling. And then the 2 is every 2 seconds for 10 iterations. So for 20 seconds that ran. And then we don't really see much going in and out of our system. We also saw commands earlier that can see all the TCPs. So we can do SAR -n dev, right? And then like every, I don't know, let's say every 2 seconds. And this would give us all of the device. And then we could also say TCP or eTCP like we saw earlier, and this would give us just every 2 seconds of transmitting on our system, right? But no, we want to capture, do a TCP dump to inspect the actual traffic on our system. So we're going to run this, and watch this. When we run it, it's going to go kind of crazy. And the reason it's kind of going crazy for 1,000 packets is because it's sending us this information out every time, generating more traffic. So this is going to generate 1,000 packets really quick. In fact, it should almost be done already. But when this is done with 1,000, it's going to count up to 1,000. Then this thing will stop over here. I'm surprised that's not at 1,000 yet. Normally it's like that quick. All right, there's our 1,000 packets. Then I say let's generate it and throw it to a file. Now, when we throw it to a file, it's going to be quiet, so it might take the system like 5 minutes to generate that. So what I did was just go ahead and generate a bunch of pings real quick for you, so that now your system's pinging a bunch in the background. Don't worry about that. But as it's pinging a bunch in the background, it's also saving it out to a file. So look, it captured those 200 really quick. And that's everything finishing in the background. And if we ls-lh on root Ubuntu pcap, root Ubuntu pcap, then there we go. We see that it's about 21 K bytes. So, you know, it's not too bad. Now, you can no longer read that file because it's not a regular file. If you do strings on root Ubuntu pcap, you'll see information about it. You can also do file on Ubuntu pcap, right? And it'll tell you what it is. It's an Ethernet capture, and its length is about that size right there. It's a pcap capture file. If file can tell you about a file, it will. Strings will also tell you if a file has certain characteristics of either being executable or not, typically. So strings is useful for that kind of stuff. So we hit that, and it says, look at you learning Linux. And then we look over here, and I say, what are all the home addresses of IPv4 and IPv6 networks? So IP-BR-ADDR. The home address of root is 127.0.0.1. Or sorry, the home address of your box on an IPv4 network is 127.0.0.1. Your IPv6 home network is ::1/128, right there. So those are your two home addresses. If you ever see those, it means it's only accepting connections from local. What does the pipe, that's this shift, that's the pipe. What does that character do within a list of commands? Well, it takes the output that was going to try to come to the screen, and it filters it in some way. So if I were to take that and say grep for LO, I would only get that line. Or if I looked for ENP1 as 0, I would only get that one line. And this doesn't look very like super useful here, because you're like, oh, well, I can see all 3 lines, sure. But what if I had 10,000 things in a file? And what if I wanted to do like a WC, like I do a WC-L against var log auth.log real quick. And I see there's only 36 lines in there. Let's go syslog. All right, there's 1,100 lines in there, but then I grep out of there root, right? And now, well, that's too many, so then I word count them, and I say, okay, there's 25. So there's 25 of them. But if I want to know where they were in the file, I can also do that. So I can cat var log syslog, right? And then I can pipe that through a number line to get a number line of everything. Then I can grep for my root, right? And then that would give me where they all exist in there, and I would know that there's approximately 25 of those lines still, right? So it's on the 2nd, the 4th, the 63rd, the 69th, all the way down to 1191, right? And anyway, so the point is there's a bunch of stuff that you can do to parse the system and parse that, but that's what the pipe character gives you, is any of these commands and the ability to send commands into the output of one command into the input of the next one and generate more and more useful filters for you to get at the data, right? Okay. After you ping Google, look at the IP route command output akin. Which route was chosen to send that ICMP message out? How do you know? So I clear the screen. I ping -C1, like www.google.com, and that went somewhere. But if I do an IPR, how do I know that that went to 172.31.1? I mean, I know that that's the only way that that could have gotten there, because I can test this right here. I can say, does 142 match? So this is how networking works, in case anybody wonders. This /24 means that the networked masked bits are 255, 255, 255, matching perfectly with the first 24 bits of this, right? That's all you really need to know is that a /24 means that these first 3 are all good. These have to match perfectly with that. Do they? So it's not going out here. And to go out here, 172.17 with a /16, these have to match perfectly. Do they match perfectly? No, they do not. So they do not match for the network, so it doesn't go out here. So I have to go out here, which is also there, but it doesn't matter. But that's how it pinged out. And then if you said, could you prove it, traceroute over to www.google.com, and your very first app-y install traceroute. If you really wanted to prove it to yourself, just get that on there real quick, rerun it. Oh, come on. And now your traceroute, your first hop was to there, like you thought. So, after you run the timeout command, so we did that net command, that netcat command earlier. So I'm going to bang netcat, or bang and actually timeout. And timeout will call the last command that we ran. So then I said, could you do it for 15 seconds? And the answer is yes, I could do it for 15 seconds. It's going to stay connected. Netcat 127.0.0.1 port 22 is going to stay connected for 15 seconds, and then it's going to drop. And that's all it's got, because that timeout command has boxed it in to only allow it to live for 15 seconds. So, what uses might you have for that timeout? Well, there's a few that I use it for. If I'm writing a shell loop over a list of servers to hit all those servers, and I suspect that one of those servers isn't going to come back, I might do that. So let me show you guys an example of that real quick, because you might say, Scott, can you show us an example? Yeah. So on my werewolf server, I can, so watch this. We'll say for I in, and then we'll do a sequence of 1 to 19, right? We'll say do ping-c1 Rocky $i sleep 1 done, right? So we're going to ping each of our boxes real quick. And let's just see if they all come back. They might all come back. Rocky 5's back up. All right. We're going to hit them all. I didn't need to sleep. We could have just ran it. Okay. They all came back. Cool. Clear the screen. Let's modify this. Let's say now SSH to each of them. And just give me 2 things as you come out of that. Give me a host name and a uptime, right? For each of those boxes. Host name, uptime. So host name, uptime out of each box. Boom, boom, boom. We're gonna have to reboot them before this weekend, so people have nice, clean systems to go into. Rocky 5, I just rebooted, so that makes sense. He's only been up 21 minutes, but okay. Reboot. You know, these are all gonna have to go down, but let's watch them real quick. Some users on Rocky 10. Okay, good. That's good. Means somebody's using the labs like they should be. When this gets to the end, I want to show you guys something. What if one of these boxes had hung? What if one of these boxes had just, like I wrote this for loop to run sequentially over each of my nodes. This is a serial connection. What if one of those hung? Well, what I always do is I do a timeout right here of like 3 seconds, because surely you can get into the system, do a host name and an uptime before that ends. But in some enterprises where you're jumping through different networks and maybe there's some kind of problem connecting to a server, 3 to 5 seconds is pretty acceptable to get through a list of servers. And then I could go do something else while these run. And then I would just have like a list of all the nodes. And then I would go up real quick, and any of my nodes that didn't respond, I knew that the timeout hit. And I would pull those out of the list, go check them real quick, kick them off to like my junior engineers to fix. This would be like if I was doing like a patching weekend and I had a few thousand servers I had to patch for the weekend. I would be hitting them with my Ansible playbook that hits all of them, and then the ones that don't respond or the ones that are down immediately get kicked over to I have a bunch of like catchers. They're doing all the other stuff, and I'm just making sure the big playbook goes, right? It's almost like if you want to think of it like they're like the blockers and go and hit stuff so that like the main payload of all the patches get done. Anyways, it doesn't really matter that much, but the point is, yeah, we can run a little loop over this stuff. So, Coffee over LAN, how's it going? It was, I think it hit 100 today in Phoenix. It was pretty close. I'm not 100% sure that it got there. It's almost 7 at night and it's 93 here still, so that's wild. So here's what we're gonna do. Oh, so then we keep asking questions. What ports was container D-listening on? You could have seen that if you'd looked in there. Looking at if stat, is the system using a large amount of its interface bandwidth? No, it's basically sitting there empty. Why or why not? Well, because we saw the overall usage was 0. And then digging deeper, I said, what does it mean to run dual stack IPv4 and IPv6 interfaces? What are the use cases for it in the industry? Why might you want to turn that functionality off? Well, that's something to think about. You come over here and you say dual stack IPv4 and IPv6, and then you go find some cool little, nowadays it's all AI, right? But you go find some stuff that people have written up about how it works, and you say, I can do it in Kubernetes. That's interesting. I can go find it. I would also add AWS, or and then go find what they're doing with it, right? All this kind of stuff. With network configuration, yeah, coffee. There's some pretty good stuff that Ansible can do for sure. There's a reason there's a whole cult of Ansible out there for sure. All right, so that was the first 4 labs, and we did the digging deeper. You guys can keep thinking about that. The next lab would have us pulling and pushing some files around and kind of stuff like that. So I think that's a valuable and useful skill. So we'll get to that here in a minute. But since it's 2 hours in, I am going to take a break real quick. Where is the? Let's see. Robodom's doing the YouTube and the Discord. Let me tell you guys, there's a Discord. You're welcome to hang out there as much or as little as you want. There are a lot of, I tell people if you get overwhelmed easily, just start down here in the beginner start here resources. This is all the beginner stuff here, right? But obviously you can just hang out and talk with people. I think it's a pretty friendly bunch. There's a bunch of off-topic stuff. You can just go do whatever. People are constantly talking about jobs and figuring out how to get jobs and all that kind of stuff. So there's a fair amount of stuff going on here. There's always events. You can always look at new events that are coming up. Tomorrow, guys are going to be doing their security engineering stuff. We got the Linux sysadmin course and the Linux security engineering course running. Those are free, and the books are out there already, right? The books are right here. If you go to the course, whoops, I can just do this. These books are out there already, so I'll drop them right here for you guys if you want them on the YouTube and the Twitch side. They are just down there, again, free. Here's the security engineering course. We're still in the process of building out the books, but they're out there for you guys if you want to use them. Yeah, coffee. I use the same header information every time on my playbooks. I have I'll just steal it from myself. Let me see. Cron tab -L. So. I always just steal this top part from myself over and over again, and then that's how I do it. So I don't always memorize the top part, but it's always the same thing, right? You always do your 3 lines for your YAML, your 3 dashes for the YAML, and then your hosts, your vars. If you have a vars file like I do, and then your gather facts true or false, and then all your tasks, right? Yeah, and coffee over LAN. If you get really heavily into Ansible, I have a whole bunch of labs on it too. So hopefully that'll give you something to do if you get bored with that. All right, let's turn this thing back on. Let's see how Ranger's doing. Hold on, how's Ranger? Look at that dog. That Ranger. I gave him too many treats today, or I'd give him more treats. Also, I've cleaned up the site. Now there's collections, so there's office, clothing, hats, bunch of stuff on the site. I've been making all kinds of cool stuff. You guys want to hear? You guys will appreciate this. Some of you guys will make fun of me, and I think that's actually funny too. But I'm colorblind, right? I'm bad colorblind. And I told the wife, I was like, "Is this green?" And then she came back finally after a couple hours because she's in Minnesota right now, and she goes, "No, that's mostly yellow." And I go, "Oh," I said, "Huh? I thought it was mostly green." And she goes, "No, Scott, that's mostly yellow." And I go, "Oh, well, I used green as my language for the thing." Anyways, so this is a little thing that we have up there. But anyways, I'm not trying to show you guys that too much. I want you guys to go browse that if you want. But I finally got them into their own little areas and stuff. So we put together a little shop because I told people you know, obviously when we get together, I'm going to be bringing merch out for the people when we get together at scale and stuff. But for people that want, you know, stuff like that just sitting around their desk, I've built some of those things for them. So that's something you guys can play with if you want. I'm going to leave this spinning over here, and I'm going to leave Ranger Cam over at the beginning of all the logs. Move this here and this here. Let me read this requirements. There are coffee mugs. Coffee. Yeah. Yeah. Have you not seen? Actually, one of them specifically was asked for. Hold on. Why don't I have it in here? I don't have it in the. I don't have it in the. I don't have it in there. Hold on. Shoot, I have messed up, guys. Yeah, because there's the sudo-i mug. It's just sudo-i. This one's been. This has been bought the most of all the things. Anyways, I don't care. All right, let me go take a little break. I'm gonna excuse me. I'm gonna put my little hourglass up here. Hold on. Hourglass. Yeah. Here's the link if you want it. Hold on. Only because you asked. It's Do All the Linux, but I will link it to you. Boom. It's also for people on YouTube. It's in the thing. But hold on. I'm gonna put this. I'm gonna go and give Ranger. Maybe I'll give Ranger a treat. Break and walk around a bit. All right, we're gonna take a break. We're gonna walk around a bit. I'm gonna turn off the camera for a minute, and then we'll come back and we'll do more labs. So you keep hanging out, guys, if you want. All right, I will be back. You guys, Robodom's in charge. Robodom's in charge of everything. Oh, one of the guys gave me a good idea. Hold on, I gotta look at what Zorgel was telling me about. Hold on. Sorry, I was wandering around, but now I just kind of want to knock this out. Nice, thanks for that coffee overland. Hopefully it's good. I've heard good things. Like I had looked up some stuff and people said that the quality was pretty good. So I didn't want to just be giving you guys garbage. Let me, hold on. What was this? Hold on, Zorgel told me about it. That weather? Oh, nice. I need to know two things about this. Can it do it via zip? Because I'm probably going to have some zip stuff going. Hold on. We'll do a ranger check. Here's ranger. There's ranger dog. Hold on. There's ranger dog. Some people, there was a ranger check earlier too. There's ranger. Look at him. Look at that dog just hanging out down there. All right, hold on. I can. It's almost, break's almost up. I'll put myself back on camera, but I'm looking at this thing real quick. I need to see two things. If it has it by zip, or if I can query by zip. Probably can't. But can I query also? Oh, that's super cool though. That would be a cool little thing to just have in one of my, because I'm always jumping. You guys know I'm always jumping through my screen sessions. Oh, hold on, I gotta fix this. There we go. Better. All right. Give me 1 second here too. I gotta fix that light. Maybe the lighting's a little. All right. Hold on. I'll do moon phases too, but it also is not. This is not designed though for historical data, which unfortunately they need. So I don't have a World Weather Online key, but I do have a Weather API key. Now Weather API might be able to do it as well. Let me actually go check that link real quick that I have. Come on, system. You're going slow. So slow. All right. Get out of here. Get out of here. Oh my fucking god, get the fuck out of here. I don't know if you guys saw that. That thing just popped up 3 fucking times in my face. Jeez. Want to use your data? Want to use your data? Want to use your data? No, like stop. I'm just trying to check out the site for a second, like for 10 seconds, please. Jeez. All right. All right. I can do Unix time start and end. That's fine. That's easy to convert. Yeah, sorry Hayes. Sometimes I just lose my shit when technology is like designed to like just like I don't want to keep moving my mouse up here. I want to read this and get out of there. So when you call this, so their API. Hold on, I'm gonna move this over here. We're still on break, guys. The API for this typically requires a key. I have a key, but also let me see. It's their marketplace. So they'll do bulk or bulk, but if they'll let me just pull it. Yeah, that was bad, Hayes. So let me tell you. Speaking of that, mentioned a desert bug. So when I was in Iraq, right, there were these little sand fleas that they look like mosquitoes, but they were so tiny that they looked like little ants. But they were little mosquito looking things, and they would bite, right? And they would get on your knuckles, like my knuckle right here, and they would feel like they were digging into the bone, and they hurt so much that you couldn't sleep, even if you had just like done stuff all day and just sweated all day and were like dead tired. They could bite so hard, and like it felt like they were grinding on the bone inside your hand, that like when I came back, I still to this day have scars on my hands from them, like along my knuckles and stuff, because it's just such a terrible part of the world. I couldn't even imagine. So you have 1 hour step history APIs available in professional experts. Yeah, okay, so I can't get a history through them, but so I do call these guys I call them every now and then with this. Actually, what's my interval? My interval's every 10 minutes that I call by default with these guys, and that's fine. Like that's all I need for them. But let's see what NOAA historical weather data is, because I wonder what I can get out of this. Because if I can just query it again, CSV from all right. So break's over. We'll get back to our stuff, but yeah. Let's ASCII formats documentation. I don't want to actually have to interact with anybody. I just want to call it via an API. Hold on. Let's see. It looks like a dead page. That's not good. That doesn't seem to be working right. Give one more shot. Alright, there you go. Select data set. Location name or identifier here. Okay. Dailies. And then I can just pick the times. Okay. Zip codes. All right. Yeah, that'll get what I need. So I was gonna write it and pull it all out. But also, if they show me how to do this with it via an API, I can just call it and then have all the data that I need, all the tasty data that I need. All right, standard created that allows reciprocal pop-ups to be sent to the company executive. Yeah, Crunk. Yeah, that one that really made me mad because I use a rollerball mouse, right? So I like don't have to move my hand nearly as much, and I had to like keep going back up every time for 3 times, and that was too many pop-ups on one page. So, all right. Anyway, so this is how my system calls, and these are the 2 cities, that's Glendale, Arizona, and Manassas, Virginia, and then you can look those up on the Open Weather map. So Open Weather is awesome if you're collecting your own data and you want it in real time and you just keep it local. I have all that, but they have, and look, I'm not going to fault anybody for this. You can pay them for up to 46 years worth of weather data, but if I can just get what I need here from NOAA, then that's how I'm going to do it. So that's the better way for me. All right. Anyway, so let's get back to these labs. We'll keep playing around on the other stuff later, but I do want to kind of focus on the stuff that we're focusing on. So let me get this crap out of the way and pull this back up. This book right here is on LeanPub if anybody needs it. It's like the only thing, well, I can't say that's the only thing that we charge for because now we have a bunch of merch and stuff, but for the longest time this was the only thing anybody could ever pay for if they wanted to. But obviously you can just do it with me here and I'll just go through it for you guys. But let's talk about this lab here, which is SSH and SCP. So I'm going to make you guys do some SSH and SCP. Well, if you want to do it with me. Here it is. I've linked it on both Twitch and YouTube. So let's go do this. And what is this lab saying to do? Well, it's popping up over here. It says learning about Linux networking by pulling and pushing files between your systems. So I have two systems here. I'm on control plane and I can SSH to node 01 and exit. So good. There we go. So you are new administrator and you need to connect from the main jump server to another server in the organization. Okay, that sounds like a task that you're going to have to probably do. You realize that you need a better understanding of the SSH connection process. So you're trying to figure out how that works, right? Connect to the other server and look at the specifics of the SSH connection. So tells us to SSH to node 01. We'll do it. SSH node 01. Connect it over, no problem. Then says to exit. So I exit and I come back to my node. Then I can connect to node 01 and I can add a V and I can say uptime. Now this is going to send over there that command and then come back to my system. See, I'm not still on that system anymore. It just connected. All we did was connect, drop in the uptime command in the shell that it gave us, and then come back to our system. In fact, the uptime command output should be right here, right at the end. Here's the sending the command uptime. Here's the response, the standard out coming back, and there's the disconnection of the shell. That's the whole shell connection. You could also do it without the V and it just looks like this. That's it. That's the whole thing. Sometimes you get a banner message of the day, and some people don't like a banner message of the day. So watch, let me show you what that looks like real quick. We were doing this the other day. People always ask me about this, so I'm just going to show you guys real quick. Pat Jorick, right, this guy. Here's the link. This one's fun. Let's just say node 01, and I'm going to use Ogre, but I'll link this to you guys that want it, right? And I'm going to grab this. This is my little block of... actually, we'll grab the whole thing right there. Boom. All right. Come back over here. SSH to node 01, VI etsy MOTD, I, and then paste. Escape : WQ. And now when I SSH to node 01, I should see that. But if I simply wanted to do that, that might be too much information to the screen, right? And in fact, the message of the day might come up, so sometimes you might just throw it because it comes up as a error, dev null like that, and it'll drop over there. Hey, thanks for the follow. I think it's Sifty and Wooming Fang. Hopefully this stuff's useful to you guys. We are not working too hard right now. We're just kind of hanging, and I'm showing you guys a little bit about the system. And then we could do more V's, which will give us a more verbose debugging, and then even more V's, which will give us more verbose debugging. So you can just be more and more verbose as you connect, and you'll just get more and more of the information about the system. Now, I always tell you guys, if you just connect to a system and it works, or you just SSH over, then who cares? Then don't go troubleshooting. Like if I gave you the keys of my truck and said, hey, go buy everybody some food or whatever, I wouldn't expect to go out in 10 minutes and see you like kicking the tires and having the hood of the truck open and being like, well, you know, it just started fine, but I decided I had to troubleshoot it for 15 minutes first. No. Now, I'd expect you to do that if it didn't start. In fact, I'd expect you to probably, you know, tell me or somebody else. But like the idea that you like always have to troubleshoot things is not true. If something just works, it works. We only pull out the -V's when we really need to, right? So I just want you guys to kind of think about that. Yeah, you got to make sure the battery's at 12.5. Some vehicles, my truck, I can put it on a setting that just shows me that the battery's being charged in real time, which is actually kind of nice because if you ever lost your alternator, you would watch the battery drain out. And I have actually seen that in my car. Well, I was in my Chevy Cruze that I used to have. I have a truck now, but when I was younger, when I was earlier in my engineering career, and I had a little Chevy Cruze. Anyway, so we looked at SSH connection over to node 01, and you should note that keys are being used, and that's why no password was asked to connect. So we're going to look at keys here in a minute, but let's just say that, yeah, we can connect over to that other system and get information out of it. Now it says you are tasked with pushing a new message of the day server or message onto that server. You know that the server has the correct etc cron tab configuration that you want to use all the other systems. So we're going to SCP from our system to that system. and then we're going to SCP source target to destination target, and we're going to push this root message of the day over to node 01. I didn't realize that was even on here. Let's go root MOTD, and oh, there's dev. That's the dev message of the day that we want to push to all the nodes, right? So I'm going to SCP root MOTD over to node 01 at etc MOTD, right? And now when I SSH to node 01, instead of seeing that old node 01, I have now overwritten that with dev. Yeah. And Crunk, that's one thing I always tell people. One of the things about Linux administration and systems administration in general is you do not want to be trying to figure out how to use your tools at 2 in the morning on a Saturday when you got called out. You want to know how to use your tools. Like you want to be, it's almost like you want to be battle ready now so that when the call comes in, you're ready to go. You might not be happy you're called out in the middle of the night, but as you become more and more the administrator, this actually came up in the Discord. Somebody posted this. Where is it? It's like a joke that popped up. Where is that thing? I think it's in memes and jokes. So where is it? It was like, you want full admin rights or not? Yeah, but being on call 24/7, getting blamed for everything, I don't know, man. But that is exactly what it's like. Do you want to be root? Oh, but now you're root, right? Like heavy is the head that wears the crown, right? Like if you want to carry the rifle, well now you got to go fight the boars when they attack the town or whatever, right? I actually just rewatched Willow yesterday. And the wife's like, I want to watch Willow with you. And I'm like, yeah, well, I watched it when she was at work. But I was working too, technically. But Willow is, they're these little tiny people that are probably about 3 feet tall. And these like little pig dog things attack their town. And they're like trying to kill them with spears and stuff. And I'm like, man, that was wild. But it's like, you want to carry the spear, but now you got to fight the giant wolf. And they're only about like 4 feet tall, these little wolf things. You know, but anyways, so where I'm going with that, I don't even know where I'm going with that. Here's how you would SCP. That's what we just did. And then you can go and just look at it real quick. So I just do a timeout 1 for an SSH over there, and it kicks me. It should send me back. Oh, I was already on node 01. If you did that, it would just connect over there. And then I can actually do an SSH to node 01 and just checksum that file and compare that to a checksum of what I've gotten. And the file should not have changed in between in the move. Checksum is a really nice, like little kind of cheap way to figure out that two things are exactly the same on two systems. You can do MD5 sums. You can do all kinds of different things. But that's kind of the way that we do those things. I gotta look for. I wonder if I have to allow. Well, anyways. Yeah, so then let's say that node 01 has a good cron tab that I want to use everywhere, right? And I said, now we have a config file that we need to pull back, maybe to give to a vendor, right? We deployed something on a system, and the vendor's like asking us, what's the config? Like it's not working the way that we thought it would, and maybe they have an older version of the config that got deployed with the newer version of the software. Who knows, right? Maybe one of the pre-sales engineers assumed some things, so the config file's wrong. Who knows? But we've got to pull it from that node back to here, and we can go checksum it over there, and then we can pull it from there to here, right? SCP from node 01, that's the end of the definition of the node. Colon tells us to start the file system path down to etc cron tab, and then we pull it back here to temp node 01.cron tab. So we pulled it back in one command, and then we checksum it locally, and it is the same thing as what it was over there with no changes. So that's kind of how that works, right? So come back over here. I'm actually going to make this book a little smaller because we need more real estate here. All right, better. All right, so I can pull this over even a little further. All right, and then we hit check, and then it says, look at you learning Linux. So over here, we were learning about pushing and pulling files. And I said, what information is added as you added a -v, a -vv, and a -vvv into the SSH command? Well, what was added to the system, what was added, and again, we can just go, we do a history command, and we say bang. In this case, we could do 9. So we want just the -v, which was 4. So we'll bang 4. There we go. Then we'll bang 9 to see history 9, right? And then the last one was bang 10. Bang is just your exclamation mark. Boom. And what happened each time was we got further and further layers of debug, right? In fact, we could... Yeah. Well, we just debugged more and more as we did the connection. And if there was something wrong, again, we would dig in. We can see, like, let me show you what we can actually see here. I'm going to clear this up, and I'm going to just do the VV real quick, or just one V. Scroll up to the top real quick, and my SSH client that's connecting out right here is looking for a bunch of different types of identity files that are down in root.ssh. That's the default place it's going to look. And it did not find all of these. And you would say, Scott, how do you know that they're not found? Well, does anybody know what a common return code for a system is if it doesn't find something? This is common across Perl did this, JavaScript does this. I don't know much other programming languages, but for sure those ones do. -1, right? Not found. That's a common one. Hey, how's it going, X3M Linux? Hopefully this stuff's useful to you. We are going through a set of labs that are on Killer Coda that I wrote for the Professional Linux Users Group. They are free. You guys can hang out in there and use them. And then we're also reviewing with the book. This is the Professional Linux Users Book of Labs for kind of a deeper understanding of it. We're asking ourselves questions. Do I understand what this means? And yeah, right here, -1 means the file doesn't exist. Now, how would I know that for sure? Like, how would I know that for sure? Well, I would ls-l root, maybe -al, by the way, root.ssh. I don't see none of that crap in there. Look at all this. A whole bunch of things that I for sure, even if I just look at them real quick, ID RSA, ID ECD SA, all these elliptical curve DSA stuff, none of that's down here. There's an authorized keys, there's my private and public version of a key, and there's my known hosts. Those are all there. So, known hosts. Now, more known hosts is all the hosts that my system knows of, right? And if I were to ever to try to connect to a system that had a different key than what's presented here, my system would go, I don't know who that is, and it would warn me before I tried to connect. That's what would happen. Then I can just delete them if they're in the way or if they're bugging me, right? Just blow away the known hosts and then just say, yeah, I rebuilt the server. I know it's different, right? Sometimes that's something that happens. So sometimes you got to get rid of your own known hosts. The ID RSA, you'll never show anybody. You never share this out with anybody. The public one can be shared far and wide. So the way this key authentication is happening, and we can see it right here, we can see exactly when it attempts and when it offers and the server accepts this key. This is the private one. I never give the actual private key to anybody. I keep it with the client, right? On this, in this type of configuration. So watch this real quick. The public one can be shared far and wide. So I'm in here and I more ID underscore RSA dot pub, and then I SSH to node 01, I CD to root.ssh, and I cat out the authorized hosts or the authorized keys. And it might surprise you that this right here is exactly this right here, because the public key, the public version of the key pair, was given over here and put into the known hosts, or the authorized keys file rather, so that then when somebody comes in and connects, they can connect from the private version of this key, which is never shared, right? That's how it works right there. All right. Zorgol, do those names have to be specific names, or can you can rename your public key files? Yes, absolutely. However, when you connect, you're going to have to give those other ones. That's the default ones that are looked for right here. These are the default ones that the SSH client will look for. You can modify. So what I would do then, if I was SSHing with a different key, it should be -i, and it's your identity file. So yeah, you would do SSH-i your private key locally. It doesn't get shared still, but that's the one that it would then be using. Yeah. Yep. So you can modify that. In fact, where I have that in the home lab is when I show you guys the how the bastions work. Var chroot in our jail, right in our chroot jail here. Right here, you see that I do bin ssh-i home streamer1.ssh cluster key, because cluster key is what actually is the private key that gets you into each of the cluster nodes inside of our werewolf. So that's actually how that works in the, this is the actual configuration that people come in when they configure, when they go to the Rocky boxes, they pass through this right here, right? So I was doing some stuff like that, but they were more complete. The objective, and to complete it, you will need to research by yourself. It's something called Over the Wire. Yeah, Linux. I tell people there's a lot of different ways to do this stuff. Like there's a lot of ways to learn. Some people, like the way my labs are designed, they're very much, they walk you through it and then make you think about it later. If you want to dig in with like this kind of stuff. I don't think any one way is more right than the other. Like I've been a college professor for 16 years, and I'm just a big fan of getting as much time with a system as possible. I think that that's kind of where there's that. Yeah, you can also specify them in the SSH config. It looks like config first and then checks for standard path. Yeah, there you go. Yeah, so you add it in there too. That'll work. Yeah. In fact, that might actually be configured. Yeah, there you go. Yeah, so that's the one it uses by default right there. Yeah, I didn't even think to go check how it's doing it in Werewolf. But yeah, that's how Werewolf knows to use that one first. So there you go. And then the strict host key checking is no, because, well, we never know what the nodes are going to come up as, because they come up different every time. So the highway is my way. All right, so let's get this out of the way. Let's go back to the actual labs we're doing. Yeah, so we did the lab, and that's all the stuff that we were kind of working on there. So then I said, when pushing the message of the day, what was the source and what was the destination file? So we had a message of the day that got pushed, and the source file was root motd on this box. Exit. More root motd. There we go. That was that file. And then we pushed it over to the other system by saying SCP from here to there. We do that as many times as we want to. It doesn't hurt nothing. Just pushing data. Who cares? But it's good to understand that we push from here to there, from there to here if we're pulling it, right? Everyone has their own way to learn. Been doing sysadmin stuff for 16 years. Nice. Yeah, Linux. I don't know if you've ever heard of our Discord. We have a professional Linux users group. It sounds like you've been doing it a long time, but I always welcome as much expertise as we can get in there. We have almost 4,000 people now. And the goal of our Discord, as some people have heard me say, Robodom's probably heard me say this over 1,000 times now, is to take people that are amateurs or hobbyists in this space and give them the skills and the just the push that they can go do this stuff professionally. Because I really do think anybody can do this stuff. I mean, I have worked with people that have all the degrees in the world, and I have worked with people that have nothing. Like one of my brothers is an infrastructure engineer 6 at a company, which is the highest they go before they move you over into an architect, and he doesn't have a single degree, because all he did was just work on systems and learn them, and he knows them better than anybody. He's been running OpenShift for his company for the last 6 years, and he knows his Kubernetes and his OpenShift better than anybody else. And I mean, it's a little sad. The other guy that knew it as well as him just died a few weeks ago. That was kind of sad, because he was only early 40s, so it was weird that his heart just stopped. But anyways, that's neither here nor there. That was my brother is like he was already the lead, but now he's even more the lead, because he's the only one that knows how that all works there, right? So, anyways, and that's a big insurance company too. Literally everybody in the U.S. would know its name. So. When pulling down the etc cron tab file, what was the source and what was the destination of the SCP command? It was exactly reversed. The source was over there, node 01 etc cron tab, and we pulled it here. This is, I tell, like, especially junior admins, sit around and just practice this. Understand how to send files and pull files, because you will be asked all the time to do something like this. Like just, you are going to be asked it often. So now that you pulled the file over, check it. Yeah. So you don't necessarily have to check some. The checksumming is more just for you to understand and trust the technology if you've never done it. But that's something that you guys kind of have to do. So yeah. Actually, I have a lot of stuff I show you guys about how you learn and that kind of stuff. We could go over that if you guys wanted, but like in general, right, there's this thing that a lot of us use in academia space called the Bloom's taxonomy, where you learn the building blocks of a thing first, like because until we have commonality of terms, we have a hard time talking to each other about things, which is one of the reasons I tell you guys to hang out with engineers. If you want to be a software engineer, if you want to be a pen tester, you need to go hang out with the software engineers and the pen testers. If you want to be a Linux engineer, you need to hang out with the Linux engineers. We have a fair amount of AWS security. We have a fair amount of all those people hanging out on the server. You need to hear how they talk to each other, because the commonality of terms makes a lot of the stuff easier to pay or to learn and understand, right? So how are questions 3 and 4 similar, and how are they different? Well, one is pushing and one is pulling, but the point is the same. It's source, destination, whichever way I'm pulling or pushing. All I'm doing is flipping where they're at. Either way, I have to know the full paths. Digging deeper, I said, what are some package managers you can use to pull or push files from a Windows system into Linux? Well, most Windows systems nowadays have built right into them. I can pull up a little command prompt here, right? Windows box, command prompt. I can CD into downloads. By the way, SCP is built right into it now, right? So I have SCP right here, right there if I needed it. But I have always used the tool for the last 20 years, pscp.exe. So I have pscp on here, and I could go pull a file. If I knew there was a file somewhere out in here, out in my environment, if I knew that there was this positions.yaml file. I don't even know what's in positions.yaml. I just know we were messing with it a while back. I can go to pscp schampine at, right? Hold on. Let's make sure it's readable. It's not readable. I don't even know what's in this. It's on my systems, but 11.245, right? And then so it's me at that, and then we go to temp positions.yaml to here, right? And then my password. Whoops. And then now temp positions. Positions.yaml. Did I not temp? Sometimes I just spell things wrong. Six 4 4. Yeah, temp. POSITI. Oh, you guys gotta stop me sometimes. YAML and YAML, right? I do that all the time. A lot of times I just do an asterisk, but oh, now the permissions are denied. What? What? Ah, at least it's there. Why is that? I don't have that on. That's funny. That's funny. It's almost like after that. That's super funny. Whatever, I don't know what process is changing that back to 600, but that is super funny. Anyway, all right, I can pull down OpenSCAP if I wanted, right? It doesn't really matter what file we're pulling down. We'll go around the problem. Doesn't really matter what I'm pulling down. Provided that, you know, I had it, and then I can just, right, whatever, it's there. If we care about Windows. We don't, but if we did, that's how we could do it. But you say, well, why would I want to care about Windows? Well, because one, you may be supporting users that are on Windows systems. Two, 99.5% of all enterprises out there are going to give you some type of Windows system. Maybe you can go slide onto a Mac, but you might as well learn how to pull stuff in and out anyways, whatever you're going to be on, because you're probably going to support people who are on that anyways. So other tools that are out there, there's all kinds of terminal sessions that people are going to ask you about. People are going to be like, well, I use this Win SCP, and I use this other tool, and I use... And at the end of the day, it's all SCP under the hood, but you might have to be able to understand the pushing and the pulling and what they're doing. I don't understand what's causing us to go back to that, but I also don't care that much. I don't know what... Yeah, something's pushing that back to 600. Some process that's active. We could go find out what's touching that process over time if we want, but I don't know. That's a really interesting... that's an interesting one right there. Maybe I have something... Hold on. It's going to bug me. Temp on its own? No. Is it like aid doing it? I don't... Yeah, anyways, I'll go look it up. I locked this box down a long time ago, and it's probably aid or something else that's changing that back. Probably for some kind of security reason. I've literally never seen that happen before, though. Like, in the system live, where it just kept going back to 600 like that. It's funny that it's doing it, but anyways. Jones, you're here. How's it going? You have to care about Windows. Who else will remove user Windows and install actual? Yeah, that's fair enough. Fair enough. Yeah. Yeah, I tell guys all the time, man, like there's things that I don't want to be involved with in the Linux world. And there's things that we do fantastically bad. Like I tell people, I don't want to, as a Linux engineer, be an identity and access management professional. I do not want to look at like user accounts all day. So what I do is my systems are designed in such a way that I trust the authority of LDAP in the organization. So I trust Active Directory. Active Directory is something that Windows has built up over the last 40 years as just being so crucial to companies. And do you know what we have to like interact with instead over in the Linux world? We have like NIS. NIS hasn't been updated in 40 years. And NIS, it's the NIS system. I've run that like at Lockheed, and it was absolutely arduous to try to keep those things up. Yeah. So I will trust those systems. And the way I always explain it, have any of you guys ever like bought a house? Have you guys ever worked with a realtor? Anybody here ever been a realtor? I've never been one of those, but I've worked with enough realtors over time and bought houses where when you walk up, there's a lockbox outside. And the realtors nowadays, they have like a little digital ID, but back in the day, the realtor would have a key from like that company or whoever was in charge of it, and they would open the lockbox and get the key, and then they would open the house and you would go in the house and do whatever you wanted, right? Then when they left, they would put the key back in the lockbox and lock it. That is exactly what I like to do with my Linux systems. The SSSD, or what used to be, we used to use Winbind and Samba, and I'm actually this is what we're doing this week in the security engineering course. This week is trusts and trusting systems and open LDAP and stuff. What we do is I just want to give anybody that's authenticated by that the ability to come to my system and get whatever permissions they're allowed to. So I basically just put that lock on the front of my servers, and as long as you come in and authenticate and are allowed, I don't ever worry about you. Never once. I got your data backed up. Your home directory gets made by Oddjob. That's a process that's running. Oddjob will make your home directories and stuff. All your home directories are shared off in some kind of NFS or some kind of off thing. And I literally don't care how you get to my system, because I do not want to be in the business of identity and access management. I will let the identity access management engineers get paid whatever they get paid, and I will be over here as a Linux engineer being very happy to not do their job. Yeah, that's exactly it. Let's push files. I worked with one. Should have just gotten licensed. Yeah. Okay. So, what other questions are there? They said, what are some package managers? Yeah. So pull and push. And what are some other secure technologies to move files in your network? Why might rsync, SFTP, FTPS, or HTTP better? for a use case, and what others, where are others using those technologies. So you may find that SFTP is used sometimes. rsync is kind of superior to SCP in when we're doing, if you're going to use if you're going to do a poor man's backup, which is just rsyncing or SCPing somewhere, rsync is superior because the archive bit allows it to just, it goes and checks everything. SCP will push over the top of stuff, and SCP that takes 5 hours will take 5 hours later. But with rsync, you can set the archive bit and it'll only change the things that have archived, right? We're not going to get into the 9 levels of backup right now, but I can assure you that is like the poorest of the poor man's way of doing it. Works perfectly fine, don't get me wrong, if you've got that architecture and you want to do it, but most of us will use like a tool that's designed like Bacula or something like that that will do our backups for us. Our security engineering course doesn't strictly deal with the data this time, but I will probably have to do an update to it because doing that kind of backup on our systems is important. I normally, well, and this is kind of a limitation with what I'm doing right now in the industry, I tend not to have data stored locally on any of my machines. It's always stored out in a big data, so I let the data guys do that. But anyways, neither here nor there. Let's look at this, and it says that we're done. But it says over here, in the enterprise, Linux engineers often find themselves pushing files up into Linux systems. They have to regularly pull log or system data to give to a vendor or third party for compliance reasons. I've had to pull a lot of data over the years for PCI compliance and PCI audit. Knowing how to move data into and out of the system is a very valuable skill. It's something that I would expect somebody that has been doing Linux for more than a couple years to be able to fluently push or pull any file. Like if you said, Scott, right now on this node, could you pull down the SSH config for the SSHD daemon? And I should be able to fluently say SCP from node 01 at Etsy, assuming I knew where it was. You might have to tell me that. SSHD underscore config back to here. I should be able to do that fluently. Like, and when I say fluent, I mean I don't have to go check the book or read the man pages for it. I should be able to do that after a couple years. I would say, like, when you first start, you could be a little shaky on some of this stuff, but over time, you guys will develop those skills where, oh, I'm sending it, like, kind of in your head as you're kind of thinking of it. I can push or I can pull anything I need to in the system, because it's an extremely valuable skill. And then understanding, how do I keep those permissions the same? Because then we also have to make sure that as we archive things, we keep permission sets there and all this other stuff that comes into it, which is, again, another reason that I think rsync is superior to just SCPing files, because rsync also has a lot of facilities for that as well. SCP can, but I don't trust it like I do rsync. So there's that. All right. Anyways, so let's keep going. Screen commands. Well, screen. We'll do the screen lab. I love screen. I think screen's a great tool. Robodom, I never store stuff on the local system. As my Linux, my whole career with Linux has been, we try to get data. Not like our systems tend to be processing systems. They're not storage systems, strictly speaking. A lot of times we'll have, because there's so much sharing of data, that the data tends to be often some kind of SAN, some kind of parallel file system that every system can touch at the same time without a major performance effect. Anyway, so here's the screen lab. I'll link this for the people that want to do it with me. Some of you guys remember back in the day we used to do these labs all the time. We were always in labs. But the reason I did the labs like this, the reason I put them up in Killer Coda is, from years of teaching like this, I've found that, years of being a college professor and that kind of stuff, I found that, the hardest thing is to get everybody in the same exact environment. So Killer Coda is my favorite because if I say, hey, are all of you in exactly the same version of Ubuntu as me? Yes, we're all in exactly the same version of Ubuntu. I don't have to spend hours setting everything up with everybody. So we're all in the same one. We all just dropped in the same exact thing with the same exact info over here. You're a new systems engineer for a small Linux-based tech company. The other engineer set you up with a tool called Screen, gave you a basic configuration file. Okay. Inspect the configuration and see the advantages you can find in this tool for your daily system activities. I use screen all the time, guys. Like I don't think anybody here's ever seen me interact with Linux, except in these shells up here, without being in screen. Because watch this. I'm on a bash prompt right now, right, in my jump box, and I can. Oh, just lost all my work. Or if I have a screen environment sitting there, just drop down back into PuTTY to my home lab, pull this up, go in as my user, and then screen-ls to see that I have a detached screen here, and I can do a screen-r to connect. That would connect. Or 25149 if I want to be verbose, right? That will connect back, and now we're in exactly the same screen session that we just were in. I have not lost any data. I am still connected over to Werewolf in a couple of instances here. I'm still connected back to just the systems here. This one's not even sudoed up, right? And I can do anything I need to now in my home lab right there. So that's the workflow that I like. Because here's the thing. I'm using a laptop, and back in the day, I used to be sitting at the office, right? And then I want to go home. I got a couple more hours on something. I tell the boss, hey, I'm getting out of here. I'm going to drive home. It's 3. I'll get home. This thing will finish up by 5. I can be on for a little later. I don't mind working after, dinner or whatever. I'll work a little later, and then I'll be done for the night. And then I can just come in the morning and check all my stuff out because all my processes are still connected. And that's one of the reasons I love a tool like Screen. So let's cat out real quick the root.screen.rc file. And this is the same one that I use right here. It's written by a guy named Christian Willis. You can go send a message if you want. And that does everything that I need it for, right? So come down here and we cat that file out. And then we can just start a screen session in our system right here. And it says that we can read a little bit about it. And I'm in a screen session now. Cool. Verify that we're in a screen session. Do a screen ls and we see that it's attached. And then I should be able to hit Control A and Shift S to split the screen along the horizontal axis, right? That's what that says here. Split the screen horizontally, Control A S, and then jump between them, Control A Tab. And down here, I'm not in a shell yet, so now here I am. I can say echo hello screen, right? Something like that, and that'll come out. But now they're both the same ones, right? So then it says here to rename, so I could go ahead and Control A Tab, and then rename the window I'm in. So Control A, Shift A, and then call this window 1, right? And hit enter. So now I see that I'm in window 1. And then I'm going to hit Control A, Control C, and now I've got a new window here. And I'm going to echo, Control A, Shift A, as it says down there, and call this window 2. Now I can hit Control A to jump back and forth between them. I can hit Control A, and, oh, you can't do Control, it's funny, you can't do Control A, N in here, but you jump between them there. Mr. The, we screen is still kind of fully replaced by TMUX. Why screen? Because I'm an old dog with old tricks. I never do new things. I never learn new things. I just stick with the old stuff. No, once something works for me, I stick with it. So I have been using Screen for so long. I hear all the time TMUX. All the STIG standards say I got to learn TMUX. I learned the bare minimum of TMUX to get by. But no, I just use Screen for stuff. The next lab is TMUX. We'll do TMUX in the next lab, guys. But yeah, I am a big fan of any productivity tool. Also, I'll tell you guys, I don't make you guys do anything. I am a true curmudgeon. I've been a curmudgeon since I was 22 years old, though. So I came back from Iraq and I looked around and I was like, I can't stand none of you. So yeah, that happened back in 2003, right? So anyways, so let's detach from the screen session, verify that it's still there, reconnect and kill the session screen, and do some logging. Logging is very important. I've told you guys the 3 levels of note-taking that I take. The very first one is always the screen session. The screen session is keeping my logs. After that I come here, and this is where I do my updates. Like I was working on the lessons yesterday. I was building out. Oh, Robedom, somebody needs to tell me when that breaks. This broke. You guys always gotta let me know when that thing breaks, because I don't always see it. But when that breaks, you guys don't get closed captioning anymore. Now closed captioning is back. All right. So let's keep doing this. So we can go in any one of these shells and hit Control A, Shift D, and it'll disconnect us, right? Now I can do a screen -ls and see that screen is still there, but now it's detached. So I can do a screen -r to reconnect, and now I'm back in that same screen with both of those open, right? They're both sitting there. So now I'm going to hit Control A, Shift K to kill the screen. And now if I do a screen -ls, there's screen, but that one was killed. And then I can just go into screen -r again. Oops. Screen -x is fine. Oh, I'm already in the screen. Okay, Shift K. We'll kill it again. Now, screen -ls. I forgot I had 2 screen sessions open. Anyways, I don't do a lot of killing a screen, but now we're going to reconnect a screen, but we're going to do a log file this time. So now, out here, if I echo hello, I don't know, something like that, and then I cat out root screen log down here, it's got all the things that we've done. All the times that we've hit enter are saved in there now. Right? Oh, it's going to be screen sessions all the way down. So screen log's going to have all that information in there now. That is one way to keep some information. I'm a big fan of, as I do commands, grabbing them and pulling them out and throwing them in a notepad, you know, so I just have notes over here. Like these are raw notes that I can go fix. I actually still have to go fix that presentation still with all those things. But anyways, that's how we do it. And then down here, I might, you know, maybe run something like this. And then I can do a Control A, Shift D to detach. And then if I tail-F on like my root screen log, I should see that that thing's still writing in real time. Should be. Yeah, whatever. We could cat it if we want. And we'll just see more and more of those lines being written. I don't do any of this stuff. This is just like playing with the system to see what's kind of available. All right, anyways, check. And then that's everything that I think that you need to know on screen. There are some pretty good little spots. Let me see if there's still this screen reference. Let me see if they still have it over here. Let's see if they still have the screen for screen. Yeah, they still have it over here. Okay. So this is like a little quick reference if you do want to use screen. Some people love, I mean, look, you guys can use anything you want. You guys have never heard me tell you what you have to use. But I will tell you, find a workflow that works for you in the system and use it. You do not have to use any one particular thing. What were we doing here? Oh, this was the, oh yeah, that was that other thing that, yeah, because we're doing climate. We're going to do some climate. I got some climate stuff to pull for somebody later. One of my buddies needs it. So, okay, over here, it asks questions. What connection information do you see when you type screen-R? I'll see that there's, oops. Well, screen-R just reconnects me, right? But then what information's captured in the root screen log.log file? Both the commands and the output. So standard input and standard error and standard output. Everything's getting thrown in that screen log. Digging deeper, what other tools exist to give you more screen real estate? Can you find a comparison between screen and tmux? And then I said, what do you prefer? Tmux is honestly the more supported and updated. Screen hasn't been updated in a long time, so that alone was enough for the government to not want to use it. So it's not allowed in STIGs. So tmux is what's required. And then I said, what's the concept of no-hup that screen uses? What does it mean to no-hup a session? What's important is that? Emacs is an OS looking for a text editor. That's funny. It's always interesting to see what admins are using. Yeah. And I tell you guys all the time, like I've never shipped a single line of real, like I've never shipped a line of production like code. Like I've never been a software engineer. I have tens of thousands of lines of things out there running that are just keeping my systems running. But that's mostly in Ansible and Bash, and then there's some Perl. And I was telling you guys the other day, it's actually funny. I have some friends that are still working for the company that subs to Lockheed Martin on a project I used to be on, and they are still using stuff that I wrote before 2013. So I left in 2013, and some of the stuff that I wrote and built is still there running. So I thought that was actually really funny too, because they're in an air-gapped environment, so they don't have to go off of OSs as much. But yeah, stuff that I built is still there, so that's hilarious to me. Anyway, so there's that. Tmux, right? We do the Tmux stuff. Same kind of thing. I didn't write the. You know what? Of all the labs, so people have edited all of my labs. Somebody did a pull request 2 nights ago. One of our guys did. People have built all the labs and helped me do all the stuff. But this is the only lab that somebody else wrote. So this is a fun little fact for you guys. This is a lab that one of the other guys wrote for us, and then I just integrated it to our labs. He said, "Hey, can I just write it into a pull request?" And I said, "Do it." So you'll also notice, it's funny, this is called Lab 6.5. So I think that's also hilarious, because he was like, "How do I get it in between 6 and 7? Because then we go into something else." And I said, just make it 6.5 and we'll just throw it in there. So there's a little bit of history for you guys. This is the only one that's not written directly by me. He copied this. You're the new Linux systems engineer for a small company. You're going to use Tmux. All right, so here we go. My crud, hopefully this stuff's useful to you. Let's inspect our Tmux file, start Tmux, and make some different Tmux stuff go. So we'll run Tmux real quick, or run the install for Tmux rather. And then let's look at the base little Tmux command. And I remember he dropped this in. So here is the base file right here that he dropped in. He got it the way that he wanted. And then it says create a Tmux session. So we do Tmux, and boom, there it is across the bottom. There's that green that we like to see at the bottom down there, right? And then we could do a Tmux ls to see that we have a Tmux session attached. Very similar to the kind of stuff that we would see in screen, right? So, and then we come down here and says Tmux is a command, usually starts with a prefix like Control B and then a key of activation. So Control plus B, and so Control and B and then Shift here. So that's a Shift and your double quotes will cause you to have 2 horizontally split screens or Tmux sessions, right? And then to create a new pane vertically from down here, I can do Control B and then Shift 5, which is Shift percent, it's percent sign, and it'll split it that way. Now I should be able to jump between them with Control B and the arrow keys to jump between them. That's pretty cool, right? I can jump between each of my sessions. Good. That's actually already pretty useful. Maybe I'll go learning that. But here we go, right? This is what our lab does. Now it says to rename our current window to window 1, which is this top window right now. We're going to do Control B and then a comma. So Control B and a comma, and it says that I can call this window 1. Boom. So now I know that I'm in window 1. And if I hit Control B and down, and then Control B and comma, I'll call this one window 2. Oh, you know what? It's funny. They're because of the Control B up. Because of the fact that I haven't switched them over somewhere else, they're the same window. So, all right, they're still the same window technically right now, right? Yeah. Interesting. Anyways, so they're different windows, but they're there. Oh, the wifey's calling me. Hold on real quick. Hey, wifey. I'm on stream, but what's up?
Oh, I was just calling to let you know we played games over at Riley's house, and now we're gonna head down to Branson.
Okay.
Tonight, so.
Okay. What game did you guys play?
Phase 10. So
Phase 10. Okay. Yeah.
that's why it took us 4 hours.
Oh wow. Okay. Well then, I'm sure the guys will be glad to know that you guys are done with that, and then you guys are going down. That'll be good. All right.
Alrighty, love you.
Love you. Bye.
Bye.
The wife is in Missouri. For people that didn't know, she went out there to hang out with one of her friends for a couple nights, and then she's coming back. So that's why I get to stream so much. Anyway, so let's keep looking at this. So we named these. We can move between our sessions by doing Control B and 0, it looks like. Come on. Control B and 0. Control B and 0. Huh. Interesting. Control B and that. That's working for me. My arrows are working. But Control B and 0 does not seem to work. Is it because I'm already in 0? Yeah, I'm not a big fan. Like, hey, you'll find with me that I don't tell a lot of people how to do stuff. Like, I show you guys things and I recommend ways of doing things. Like I recommend that engineers learn VI and Vim, but I don't make them do it. I just tell them that they're probably gonna get made fun of if they don't. But like, I don't make fun of them myself. And then it says Control B and W will. Oh, that'll show me all of them, huh? That's interesting. View all sessions in their associated windows and panes. Move your arrow. Okay. Oh, geez. That looks like I got like all kinds of control here. All right. That's interesting. So, let's get past that. Tmux sessions. All right. So now we're going to detach them all. So Control B and D. And lowercase d, apparently. That's cool. Kills it, right? Or detaches from it. Tmux ls will show it to me again. Tmux dash tmux a dash t0 will reconnect to it. Okay. And then tmux oh man, that's sad. Tmux list sessions, no server. All right. Then we can make a new one. Tmux. We can pipe and output apparently. Do our little sleep. Control B and D to get out. He actually just mirrored my lab but did it in Tmux in case you guys were wondering. And then if I do a tail dash F on home logs Tmux. There we go. That's cool. We could do a Tmux dash A or Tmux A will just reconnect apparently. And then Control C. Tmux kill dash server. That going to Control B was making me move my hand too much. My hand didn't like being like I didn't know where my shit control key was again. All right, anyways, so there we go. So check it. That's our lab. Over here it says when you cap the file Tmux, what values in there stand out to you. If you're finished with the lab, ask what you might want to change. So if we cap that file. I don't really, I mean, history limit's fine. 50,000 is pretty good. Display time, I'm sure that's fine. You can have refresh interval. You can set all these. I don't really have any preference on any of these things, so I wouldn't really change any of these. That looks fine to me. You can bind things if you want to, so that's good. And then it looks like there's a bind R source file. Good. How's this different than screen? In your command, well, it's Control A in screen and it's Control B in Tmux, so that's fine. One of the guys mentioned that he just maps it to Control A in Tmux and then he does all the same stuff, and I'm like, that might be fine. That might be okay. So apparently I can bind whatever I want too. So when you did Control B to see all the sessions, what did you see? Is that what you expected? Yeah, we had the 3 sessions, right? So there's that. And then digging deeper, what other tools exist out there to give you more screen real estate? Can you find a comparison between screen and Tmux? And then why might it be important to log everything? Well, just because that makes it easier to go search things later, right? And then look at the site Teammate. Oh, I've never even played with this. What's Teammate? And it's instant terminal share. Oh, okay. Yeah, actually, we use this. We use this at some of the colleges that I've worked with, where we can just give you a line to throw in and you just SSH right into our systems. So Teammate's actually a pretty cool little service. And you can run your own Teammate. You don't have to use theirs if you don't want. So if you don't want to do it like this, you can just set it up on your own. So port things to NeoVim. Yeah. All right. So next one. Oh, so then we get out of into the little productivity stuff. And we get back over into doing sysadmin type stuff, which is like working with DNS and making sure everything works the ways that we expect and that kind of stuff. So our next lab will be DNS and finding resources. So we'll do this one here in a little bit. What's our time at? Man, we're getting up there on time. Let's take a little break again. I'll give you guys a little bit of time to think. Yeah. This one's pretty straightforward. This one's pretty, I would even call it simple, but that's how my labs start. Yeah. So that's how they all start. Like we get more advanced as we go. In fact, I would advise if people are like, "Hey, I like some of the stuff, but I want to do more advanced stuff," in my labs over here, some of the stuff that's a little more advanced is down in like the Ansible. I'm showing like this is very like starting out sysadmin stuff, but then I have some Kubernetes stuff. I have a bunch of the Kubernetes certs if anybody cares. But Ansible is where I've built a lot of my career. I tell you guys, I manage systems that have, well, currently none of them are over 10,000, but I manage multiple systems that have over 2,000 systems to them, high performance compute clusters, and I have built my career around Ansible. Like not completely. I mean, I do other things, but Ansible's a big part of it. So I do think you guys can do a lot with it without being some kind of weird like niche expert. You can just understand it broadly and do very well with it. So all right, let's take a real quick break. I'm gonna put that up. And then we'll put up Hourglass. That one will be fun. People will come in and be like, "What the hell is this guy doing? Who's this ant?" If you guys are familiar with that, awesome. Take a break. Walk around. All right, take a break. Walk around a bit. I'll be back. Robodom's in charge, or Robodom or Hayes. One of you two. Maybe Robodom. Robodom's in charge. I might call the wife back for a minute too. All right, keep taking a break, guys. I'm just wandering around a little bit, stretching out. Ugh. And we'll do some working with DNS next. Robedom, you keeping them all under control? I don't see anything too bad going on. Looks like you guys are good. I'll be back. Just walking around, I get to sit there all night, so a little bit of walking. What are all these fun noises I'm hearing from the other room? Hold on. Thanks for the follow. Lost Marble. Hopefully this stuff's useful to you. We are hanging out for a few more minutes. I'm just kind of walking it out a little bit, and then we'll get back to doing system stuff. We have 2 courses. I haven't even mentioned them. I haven't mentioned them in a while. They're free. They're in our Discord. You guys can hop down there if you want. All right. We're almost done with break. I'm getting back to it. Let me check if I can get this stupid thing to... Let's see here. That stupid bug. All right. That's too funny. All right. Almost done with break. Ranger, oh, I didn't pull up Ranger Cam. Hold on, let's get Ranger Cam back up. How's Ranger doing? How is Ranger doing? That dog. He has not moved. He's not moved since the start. Actually, he was missing earlier, but he's just laying there. He's out. He is conked out. For those of you that don't know Ranger, that's my dog. He hangs out downstairs. He guards the house. That's pretty much it. That's all he does, right there. He used to bark when people would come around, but now he just lays there. So there you go. All right, let's get back to this. So I started the lab already, and we'll appreciate Ranger for a few more seconds here, and then we'll get to it. But the lab says your team's going to be doing some DNS work, and you have to figure out how to use your tools in your Linux system. Use host, dig, NS lookup to figure out what type of information they can show you. Check the contents of etcresolve.conf, and then do a trace route to a couple of systems. See how our systems are resolving, and see what's happening within our system. What does it mean to resolve? That kind of stuff. So we'll do that, and we'll wait for 30 more seconds for Ranger to be just laying around. So. All right, 20 more seconds. Give people time to walk back from whatever they were doing, hanging out, working on stuff, and then we'll go. We will go. All right. So, team's working on some DNS stuff. Use host to examine about Google. So we'll do host www.google.com. And it gives us an IPv4 and an IPv6 record about Google. So our system understands that Google exists out there. It did a layer 7 request of DNS all the way somewhere, all the way back, and resolved it. But how did it do that? Like, what was the process of that, right? So we're going to look at dig next. Dig's another command you got. And dig is going to go, and it's going to give you some information. It's going to give you an IPv4 address. By the way, it's different than what you got from host, but it's pretty similar. It's in the same general area, depending on how they have their subnets. But it is using an A record. A records map IP addresses to IPv4 addresses, as it were, to names that we can easily remember, called DNS names, right? And if it was a quad A record, so 4 A's, it would be an IPv6 address, right? That would be an IPv6 address is a quad A record. We can do that same dig, I believe we found, with like a -6, and it'll do the same thing. Maybe that doesn't work. But it'll tell us if it can connect out, or actually try to connect locally to our own box on port 53, and the connection was refused. So we're not running a IPv6 DNS record locally with digs. So that's fine. We're not really too worried about that. But how many A records do you see? We just see the one. And then what server was used for the DNS query? We went to 8.8.8.8. That's where we went. Up here, we don't know where we went, but that's why dig's a little better. So then we're going to cat our etcresolve.conf and say, well, there we go. Name server was 8.8.8.8. And then there's also this 1.1.1.1. So, okay, so we can go and throw those both down in the resolve.conf. And then it says that we can use traceroute. So traceroute should be installed to see what our path would be to get to Google's. So how our system is getting out to Google once it's already done a name resolution. So we used www.google.com. Our system had to go do a name resolution, and then this is all the paths that it took. In this case where you see this, that means that something didn't respond along the path. Something was designed to come out. I'm not exactly sure if they're part of DNS utils. I can tell you on the Red Hat side. I don't know how to do it on Ubuntu side. On the Red Hat side, what's going on here, server? What are you doing? Let's just go to like Rocky 1 real quick. And I can tell you this. So dig, how did we get dig on this system? It came in from bind utils. And what was the other one you were asking about? And host. Host comes from bind. Yeah, so bind utils are where they come from, which are just the DNS stuff. Yeah. So I know that there. I'm not sure exactly. So if we have dpkg-l grep for see if we have bind 9 DNS utils. Okay, so then we could say dpkg-l bind 9 DNS utils. What is that freaking command? I got it somewhere in my notes. I don't use enough Ubuntu professionally to know this one right off, but it's hold on. It is all the files or the packages. So here's list the. Oh yeah, dash capital L. Yeah, there's dash capital L, and then what were you asking about? It was dig and host. Dig host. Yeah, so dig came from it. Host might have came from somewhere else, but that's how I would find it anyways. So dpackage-l will give me dash capital L will give me everything that bind utils put on the system, the package, and then I just looked for dig and host, but I only see dig. So I don't know where host came from. That would probably take a little bit more. It might be in bind 9 host. So yeah, that's where host came from. So dig. Yeah, there you go. Yeah, so that's where they both came from. Bind 9 dig and bind 9 host, or bind 9 DNS utils and then bind 9 host. Yeah, that's where they came from. Yeah. But that's how I would find it, because I don't use like Ubuntu professionally. Like I only use Ubuntu in these labs for you guys, and it was only to deconflict. Like I was telling you guys, normally if I say, hey, let's get in our labs, 100 people will have 100 different labs, right? So the reason I like Killer Coda so much is I show you the lab, you guys jump in the exact same lab with me, and we're in the exact same system. But because of that, I'm not using Red Hat, which is, the last 20 years of my career has been almost exclusively Red Hat. Although a fair amount of SUSE as well. Or SUSE as they call it, because it's a German word, right? But I can never remember the name. I can never remember how to pronounce it. But it's SLES to us because it's SUSE Linux Enterprise, right? So now you've looked around with tools that you have. Let's figure out the order that your system looks up resources in. This is important for you guys exactly once. Once you know this, what I'm about to show you, you'll just know. But some people, again, you won't know this until somebody shows it to you, and then once you show it to you, you'll go, oh, that's how it works? Okay, that's easy, right? Like, so how does our system know the order that it's going to look stuff up in, right? So let's look at this file called etsy-nsswitch.com. And this file right here for hosts is going to look at local files first, and then it's going to look at DNS. So if I cat etsy hosts, which is its local host file, I do not have Google in here. So if I go to ping www.google.com, I have to go to DNS to resolve that, right? So we're going to verify that this is all true by setting up our records and breaking the way that our system resolves names. So we're going to go do that, and we're going to do it for fun, and then we're going to put it back. So we'll cat our etsy NS switch out and see that hosts our files in DNS like we saw right there. Boom. That's what we expect. And then we curl Google real quick, and we see that Google has Google all over in it, right? It's a Google name. And then we do a host for Yahoo, and Yahoo has a bunch of addresses. And we could take this address and use it, or this one right here might still work. But let's just go ahead and try that one real quick, because that one might still work. Let's curl. Just for checking, curl 74 .6.231.21. That one might still be Yahoo. Yeah, so this one shows Yahoo all over, even though it's an error page. But then let's curl. So we put that in. So if we cat our Etsy host, we put that at the end of our Etsy host. That's what this little line right here did. It just dropped it at the end of the file, right? So track with me here real quick. Now we're going to curl Google, and our system is not going to go out and resolve DNS. It's going to look locally. It's going to then curl the page, and we're going to get all of that Yahoo stuff instead of our Google stuff. And then we're going to say, no. Switch it, right? So now we're going to change the order so that Etsy NS switch uses DNS first. So we're going to VI Etsy NS switch here, and I'm going to use DNS first. So I'm going to actually just comment out this line, paste it, and switch the DNS and the files real quick. Files, files, right? Oops. Now that same exact command should now be all Google again, because our system is now using DNS resolution first before names, local hosts, right? So we just broke it, proved it, and then we can just fix it back. vi etsy nsswitch.conf ddx escape : wq, and then now Google is back to Google, right? Like it should be. Oh, wait, what did I do? Oh God, you guys. Yeah. Oh, well, we gotta go take it. If we set that back, then you gotta take your Etsy host, Shift G, DD, get out of there. There, right there, boom, right. So there we go. Dig's not working for you. Communication to timed out on request to your router. So Dig should try to look locally first if you have it, and then it goes over. I'm trying to think. You can always, so cat Etsy, nope, resolve. This is actually something I don't think I asked in here. I think that's actually the end of the lab right there. Oh wait, oh, my validation failed because I fixed it back. This only completes. Hold on, I'll show you guys how this completes. Watch. This lab only completes if you have that Google and Etsy host. So we'll lie. Doesn't matter. Now we can finish the lab. The lab was busted because I took Google out, but anyways, it's back in there. So we cheated on the lab because we knew what it was looking for. Look at you learning Linux. One thing I was going to show you guys, that if you cat out your Etsy resolve.conf, you'll see the two that it's using, but these are neither of these are local. So a lot of times companies will have a local one or a couple of local name resolutions, especially if you're in an air-gapped system, because you can't get out to the world anyways. Plus, these servers don't know what's going on in your internal system. So a lot of companies will run their own internal bind. Now, I will tell you, when I run Oracle clusters, when I run high availability systems between two nodes, I always have the nodes have their information in Etsy hosts. And you might say, that sounds a little arduous. Well, it's not, because you can have tools do it for you. You do not, guys, things that you have to do manually are arduous. But if I can cat Etsy host right here, guess what? There's everything in the cluster. Even boxes this box has no business talking to. This box Rocky 1 knows all of the other ones because it's populated through the Werewolf config. And as we add nodes to Werewolf or pull nodes out, they get dropped in here or pulled out as the systems get rebuilt, right? Because we use Werewolf because then we can just wipe these nodes like nothing. Just wipe them, bring them up clean. Wipe them, bring them up clean, over and over again. That's how we do that. All right. So, anyways, that's the main things that I want you guys to know about DNS. Then over here on the questions, what types of addresses are returned? IPv4, IPv6. What answers did you get back from traceroute? All the devices along the path in order. If you get a bunch of just asterisks from traceroute, the device is set to not respond to ICMP requests, echo requests. It doesn't give an echo reply back. What is the default order of host lookup in the etsy.nswitch.conf file? It looks at local hosts first, local files. It's called files, and it's Etsy hosts, and then it's DNS resolution. What happened when you put the Yahoo address in Etsy hosts for Google? Why did it change? Well, because we were looking at Etsy hosts first, so we went to Yahoo instead of Google. So we broke the system, but we did it to understand how our system works. A lot of times, like when we first learn things, like it's, if any of you guys have ever seen, like where you teach kids, that you teach them something and then you show them something else and you let them compare the two things. If you ever watch Sesame Street, that's how they taught kids things. They said one of these things is not like the others, and then you would go, oh, that one's blue and those four are red, and I'm colorblind, so they're actually like green and yellow. But the point is, I knew that one was different than the other. So a lot of times we compare things, and the reason we broke that in our system was to understand that one, users one day are probably going to get you with that anyways. So, all right, anyways, so name server, it's fault of network. Maybe it's how to fix my recent problem when trying to connect to some website. That could be it, Mr. Yeah, that could absolutely be it. In fact, one of the things I would do is don't only have these ones. There's another one that I tend to use. Hold on, I got to pull up my. Hold on, I got to go to my resolution here to tell you. The ones that I use, the three that I use in my home are, I use 1.1.1.1. I use 8.8.8.8. So 8.8.8.8 is Google. All ones are somebody else, and then I use this one. I'll drop this one in for you too. This is the one that Cisco. What is it? It's open something. Right there. Yeah. That's another one that I use. Those three right there, pretty clean for most things. It's okay. I'm on VMware logged in killer. All right. Yeah. So that's that, and that is that lab. Pretty much done. Let's pull it up back here. What are some common ports for DNS? 53 tends to be 53. If you struggle remembering that, Amazon uses Amazon Route 53 as their DNS, right? Why does it use both TCP and UDP? And which protocol is used for which type of traffic? TCP. I actually don't remember the answer to that. I can tell you one thing for certain though. If you don't allow TCP and UDP through for your in your Kubernetes clusters when you're making network policies, you're gonna have all kinds of problems. So you have to, TCP and UDP are both used in requests for DNS. Gosh, why is it? Well, I'm gonna let one of you guys go figure that out. And then Cloudflare, that's it. Yeah, that's right, Cloudflare. And you filter traffic to only allow UDP or TCP on DNS port. What types of name resolution issues might you run into? I'll tell you for sure, your Kubernetes will stop working. And when it's setting up DNS and using it for deployments, why is it so important to understand client timeout? Why is it so important to know that you can't control? Oh, this is actually important. So sometimes when we flip from like a blue-green deployment, or we flip to like a one-box deployment for users, we do that in DNS. Sometimes we do it on load balancers, but sometimes we also do it in DNS. And the reason it's different is with DNS, we're assuming that all the clients that are connecting are good hosts. And most client timeouts are 5 minutes. But a client does not have to time out ever. They could just remember the DNS information you told them. They could be a bad client. They could be a bad actor. So it's important to understand that typically when DNS resolution, when we change using DNS, we give it a little extra time for clients, like 10 minutes to time out. But also you can expect, if a client is poorly configured for whatever reason, that up to 2 days people can still be connecting to that old DNS information. So that's an important thing to understand. If you're doing live migrations of sites, DNS, even DNS that's flipped, even DNS that all new requests are coming in and going properly like they should, if you are doing DNS changes to do your flip overs, you do not control what the client knows. That's an important thing to understand there. If I was writing a client and I never wanted to forget DNS information, I do not have to. So just know that that's an important little part of that. So yeah, accidentally fix your problem. That's funny. It's so there was a guy, Howard Taylor, who used to write Schlock Mercenary, and I loved Schlock Mercenary. It's still available. You still go buy it. In fact, he's writing a new one. But God, it was such a fun webcomic. But one of the things he talks about is like how an engineer goes, huh, that's interesting, or a scientist goes, huh, that's interesting. I don't know why that works, or huh, that's interesting. I don't know why that doesn't work anymore. And it's just kind of and that's like kind of a joke around engineering teams for a long time too. I hate when I don't know why it works, but it works. I that's like one of the worst ones, because then everybody, all the project managers and all the other people are like, let's go. They're like packing up and going, and you're still sitting there going, it doesn't work. I don't understand why it works. So that's the problem now. And I would probably, I don't dwell on stuff a lot as an engineer, but I would definitely not be able to handle that. Hey, Sir Caffeine, thanks for stopping by. Thanks for hanging out. We got to go do, what's our next one? We're going to do some variables and logic, right? We're going to do some bash logic, right? By the way, bash logic is logic. Logic is logic. It doesn't matter how you learn it. Computer science, the basic computer science stuff is all the same. If you learn it here, it's the same as if you go to any other language, right? So it's just the structures, the syntax is different. The syntax is different. The logic itself does not change. So when you learn conditions and logic, and then the way that we do conditional and counting loops and stuff, that is the kind of stuff that's really valuable to you. So yeah, absolutely, Sir Caffeine. Yeah, get some. I have work tomorrow too, but I got to get up and work out in the morning, so that'll be fun. Well, Bash is good on the OS level, that's for sure. It's definitely not gonna be up there with anything that you compile, obviously, but Bash will do what you need. Bash is like Brondo; it's got what plants crave. So, anyways, let's see if we can get our Bash working the way that we want. So here's a lab link. I'll link it to you guys that want to do the lab with me. Some of you guys, this will be a breeze. Some of you guys, this will be the first stuff. But I can promise you one thing. I'm going to promise you guys the same thing that I've promised all my college students over all the years as I've explained this. You understand logic. I know you understand logic. And most people are like, I struggle with it. I'm like, no, the logic part's easy. I promise you guys are good at the logic stuff. In fact, you would have crashed your car on the way to the college, or you would have crashed your car on the way to work this morning if you didn't know logic. The logic stuff's easy. It's a syntax that gets people. So I'm going to try to make this as painless as possible, right? I don't think this is super painful. The lab will walk you through everything, so that's cool. But yeah, let's do a little bit of variables and conditional logic real quick here. So you're a new system admin at the company. You've decided you need to start gathering system information so you can use it in scripts. You know that this will give you more capabilities for automation and collection of the system state. So we want to know the system state so that we can do things in a system, right? This is very valuable. So you're going to check your bash environment variables. You're going to create some variables with some system data, maybe the state of the system as you found it. And then we're going to output those variables to the screen based on conditions. That's all we're going to do. So 4 ways to get information about the system. We can print env. That'll just dump a bunch of environment stuff to the screen. We can do env, which actually dumps pretty much the exact same stuff. I think env and print env probably alias to the same command. Probably go look that up. We can do declare-p. I like this one. Declare just gives you all kinds of similar information, but more. And then I think set probably takes the case. It's probably got the most. Set shows you so many things about the system. So many things about how it was called and what's running and all the things that are going on inside your shell. So these are 4 ways to get environmental variables out of your shell. Print env and env will probably be what most of you use in your career. If you go spend time, like Sending Grounds is one of the guys in our Discord, and he also streams. Robedom, I don't know if you're around and you give him a shout out, but Sending Grounds is great. He digs into this stuff a lot, and he does this stuff professionally way deeper than I do. Like, I probably have never written a bash script more than like 10 pages in my career. But he is a bash programmer. He actually does programming of system stuff in bash. It's pretty wild what he does. So he'll if we get him streaming again, we'll get more of that. But if we look at all these 16, 16, yeah, those are pretty much the same, and 64 and 65 are the number of lines in that one. So significantly more output on these last two. And we're going to just keep going here, and we're going to say test the output of a variable named $name. So we just echo name, and there's nothing in it. So what we just did to this, what we just told the system to do was just echo out. So in standard input, we said echo $name, and we told the system to go find a box labeled name and give us the contents back to standard out. But there's nothing in it. So there's nothing in it, so it gave us nothing out, right? That makes sense, right? But the name of a variable is just a label slapped on the outside of a package. Some languages care more about what that package is and the structure of it. Like, is it an integer? Is it a float? Is it all these other things that it can be? But we, right now, have just said, go look at this box, and the box happened to be empty. The label on the outside of the box was name. We use $sign to tell it to go look for that name, right? All right. So now we're going to say uname, and uname will tell us Linux. And then we're going to say name is equal to uname. So the uname command dropped this out. And now we use name right here. This is one equal sign in most programming languages is not an equality operator. It's a set. It is actually setting the value over here, kind of like a little dump truck, over into here in name. So now when we echo name out to the screen, it's going to go look in there, and it's going to find the value that's here that was put into there, and we would expect it to be exactly the same output as what was in the command. People tend to call that, this right here, they tend to call that interpolation. So I call something in real time, but I want you to put something else in. So an easy way to see that is I'm in root, and I ls, there's no file in here called file. So I touch file, and then I want to interpolate the host name of the system on it. So I do that. And then now you just saw me put touch file.hostname, backtick hostname backtick. But what came out was the actual output from the command of hostname. Do you guys see that? So this is like a valuable thing to understanding what's kind of going on in a system. Variables are being put over here, they're being called. Putting them over there, calling them. There's a bunch of things that we can do to continue. In fact, one of the things I probably should update on this lab, I think I am going to update on this lab, is put array logic in here. Because array logic is then we open up a box, and in that box, like if you guys opened up like a box, for me, it's like a box of ammo. You open a box of ammo, and then there's a bunch of boxes inside of it, and you're like, and then you got to open the next box, and then you open it, and there's all the ammo or whatever. Well, it's the same kind of thing here with an array. You're opening a box and finding a bunch of values, but how do you reference the third value? That's like the crux of it. How do you pull these things out? Yeah, Crunkmaster, that's okay. This is most all this is recorded somewhere too. Also, plus you could just do the labs and then ask me questions later too. That's also possible. We'll wait for you. I think you got about five more seconds or so. Yeah, Rob. No, I think YouTube's putting ads in, but I think they put them in later. I think they come up later or whatever. So, all right. So, we're gonna go look at. I could do some PS1. Yeah, I actually show you guys because this is a weird thing for people that have been in Linux a lot. We are root on this system, but the PS1 variable does not look like a normal root because normally we have a pound sign. And I tell people that a lot. These labs, people are like, how do I know I'm root? Well, who am I and ID? These are the things. But it's weird to be at a $sign and not be root. I don't look at a $sign ever. Like I'm one of those guys who, even though it's bad practice, I'm always root in an environment. I never go mess around or whatever. So yeah. No, Rob, no, I appreciate that. you letting the people know about that stuff. So let's go capture a couple other values that are out there. So we're gonna do something that's kind of interesting. Let me show you guys something. We're gonna do this first command and the second command real quick, just for fun. And then I'm gonna show you guys something about the first command. So if I PSEF and there's nothing, and I do an echo $?? Does anybody know what that $? Does? It's a specific. It's what we call a special variable. You can't use it yourself. The system uses it. But I'm going to show you the other one real quick, and then we're going to do that. And oh, I'm also going to tell you one other thing that maybe some people don't know if you haven't been around. HTTPD is not running on this system, so it's not found with the grep. And SSHD is running on the system, so it is found with the grep. So what are we seeing here? That 1 and that 0 are becoming analogous to something for us, right? I like it. Yeah, it's doing something for us now that we can logically do. And with our scripts, if we have to write something to go check 1,000 systems, and we need to just know if HTTP is on or off, and then do some work based on if it is. Now we've captured at least the truth and the false. Do you guys see that? Now, engineers typically use 1 for true and 0 for false. But right here, would you guys agree that if HTTPD is off, we're going to use 1 as false for now, and SSHD is on, and we're going to use 0 for true for now. But with the understanding that that is not normally the way we do it as engineers. But that's the way the system's presenting it to us. So what we do is it's almost like we have to flip it in our minds so that we can do this lab. But it is accurate. And it would allow you to, what I always call this right here is I'm just, because think about it, with me, I can just do this command. And I could tell you guys that means we see SSHD running, we're good. For now on, for the rest of the time you're an admin, you can always just do that command and see it. But how do we make the system understand the 1 and the 0? Because I don't want to be up at 2 a.m. doing the change that this is going to do to see that the system's up and then update the cryptographic procedures that SSHD is allowed to accept and then restart it or something, right? I don't want to be up to do that. I want my system, my script to do it. So I have to find out if SSHD was already up, right? I don't know. That's not a great example because you wouldn't be connecting if SSHD wasn't up. But in general, yeah. Yeah. This is just really just for the logic part of it. But yeah. Can we verify that we saw the things that we expect? Yes. By the way, grep does really weird things sometimes. So 0 and 1. This is the only time normally that I would tell you to use grep like this. When I just want to, yes, it's there, or no, it's not there. Because grep will give you like 127 error codes and stuff. They'll give you all kinds of weird error codes. So now let's talk about decision structures from like a strictly computer science standpoint real quick, right? There's 3 types of decisions. There are single alternatives, dual alternatives, and multiple alternatives. There are nuances within those, but let's talk about the base parts of them. So test each of these structures with the variables from the previous step. When we look at like code execution in a system, by default it starts at the top and runs down through. That's procedural, right? Just sequential execution. Then people take all kinds of things like functions and cause things to be called. So you got reusable blocks of code, and then people have objects, so the object exists, and then you call it and it instantiates it when it's needed, or you've got some warmed up and you call. There's all kinds of things you guys can do with code. I do not claim to be any great coder in that space. That's not even what I do. But what I can do is test to see if something is on or off. So right here, we have a right here. This is a single alternative structure. And what do I mean by a single alternative structure? Well, we say if, and we do a test. Now, I'm going to prove something to you guys here real quick in Bash that maybe some of you don't know. This is maybe a fun little bit of trivia. The command test is actually encompassed by those square brackets. I could write the word test right here and do the same exact thing as I just did like this. But Not a lot of us like that because I don't get to see, and this stems back, for me, it stems back from Perl, but for some of you guys, it's probably even C and earlier. But this is very easy and supportable for somebody later in my script to come through and say, this is where Scott's checking something. Anytime there's square brackets, that's where something's being tested, right? So that's better to me than this. This, your eyes will just flip right over going down a page. But this is very sustainable. And as the kind of like senior guys around our Discord will tell you, you're writing code for the people that come after you. And I'll tell you, I don't know how many times over my career, it's been a lot, where I come and I look at something, I go, who the hell wrote, oh shit, it's my name at the top, right? So anyway, so we look at this, and this is a single alternative because it says if this, then do this, but there's no other alternative structure. So what's happening here is if we were coming procedurally down and we came upon this and our system ran this test and this was not true, it would go to the next line of code and keep executing. There is no forced alternative here. This is simply, it's like I was walking home and I said in my head as I walked home, if I see a stick, I'm going to pick it up. If I see a stick, I'm going to pick it up, and then I never see a stick. And I just get to the end and I get home and I'm like, oh, I didn't get to do that little block. I never did that block of code ever, right? I just never saw a stick, never. That's a single alternative structure. There's no forced path to change. All the other ones are going to force a path, but single alternatives don't. If it happens, it happens. If not, nothing. We're going to compare that now to a dual alternative structure. A dual alternative structure is a fork in the road. You're walking home and there's a left and a right. You have to pick one of them, or you're going to just walk into the lake or whatever. I don't know why you live by a lake, but you have to pick a decision. You have to go one way or the other. And these are if then else, right? So if this, then we see, oops, I had too much other stuff running. If this, then HTTP is not running, else, and that's a catch-all, echo HTTP, it is running. So HTTP is not running, so that's no good. And then down here, we know that SSH is equal to 0, so SSHD is running in this case. But we can mess with that. We can say SSHD check is equal to 1, just to mess with it. And then I can run that, and I can say that it's not running. And then I can change it back to 0, because that's the correct answer. And I can see that it is running again. It's not actually changed in the system. It's just my checking of this. But this is a dual alternative structure because this forces a decision. It's either this, if this, then this, else that. If it's 90% this way and 10% this way, I don't know. If it's 100% this way and never this way, I don't know either. But I'm forcing an alternative structure. I'm forcing you to make a decision. Well, the program to make a decision, right? If you want to think of it like that. All right, anyways. Alternatively, we can have multiple decisions, and that is a case check. So a case structure looks like this. We say case. Oh, by the way, with if you're going to test something in bash, you always have to turn it off with phi. So if is turned off by phi, and case is turned off with esac, because it's case backwards. They're brilliant, I know. So case SSHD check in either 0 or 1. Those are two things that it could be. Or the catch-all in this one, which is just a double asterisks for us here, is echo something is really wrong because you're not a 0 or a 1. So I see SSHD is running. So then I go and I change my check to 1, and I see that it is not running. And then I change my check to like 1, 2, 3, and then I see something is really wrong because it's outside of my defined cases. But I have a catch-all for it. This is still making a decision, but it's a multiple alternative. So again, back to this. You have single alternatives, dual alternatives, and multiple alternative structures. Those are the main primary structures. There you go. So you've done some conditional logic in bash. So let's go forward and do some more tests. Oh, so then it has us do more tests. Oh, I add an inclusive. So or is inclusive because if I say I did this or that, either one of those being true would make the condition of us talking true. If I said this and that are true, but you find out later one of them's not, you would say that I lied to you because both of them have to be true when I use and. So or is to be inclusive and is to be exclusive, right? So I come in here and I say if this and this. So let's go change SSH check back to the right number, which is 0, right? And then we'll run this check and say this and this are true. Then the system's good. And then we say this or this is true, and it says the system is good. And I go check, I can go ahead and change SSD check back to that BS from earlier. And this is going to be good. The or is going to be good because, guys, only one or the other has to be true. But the and is not going to be good because they both have to be true. Hey, Blues Doggy, thanks for the Prime. You know, you guys can use those anywhere. You use them here. It's always good. I saw actually some of the bigger streamers, like I was watching Baru earlier, and he was like, yeah, he goes, I know a bunch of you guys are letting Bezos win because you got your primes. You should be using your prime. I thought that was really funny because he got like 40 people to subscribe just by saying that. I thought that was funny because he has, you know, Baru averages, I don't know, 2,000 to 4,000 people probably on average, 2,000 to 4,000 people on average in the stream. So he stays pretty busy. But yeah, he's like, you're letting you're letting him keep money in his pocket. And he's like, you're literally taking money out of his pocket. So a bunch of people were giving him their primes. I thought that was funny. So I said, look at you learning Linux. You captured variables, did decision-based output, and then looked at and or logic. More information can be found here. This is one of my favorite things to show people because it is dated information, very dated, but it is so good. If you guys don't use tldp.org, the Linux documentation project is the place that I go when I don't remember like a selection or a test. But this is a really good bash how-to. So I'm going to link it to you guys if you guys need it. So there you go. There you go. Oh, by the way, I have not seen... Oh, apparently I have not seen a single scroll over here on the right for a while. Amber, I apologize. I missed you coming in. Yeah, I missed all that stuff. Yeah, I apologize for that. I was up walking around and stuff, so... Walking around, I think, when you got here. But, yeah, guys, all the process that I've been doing right now, and I've spent 4 hours to do 8 labs with you guys that wanted to do them with me. We're up to here. We did 9 labs now. Wait a minute. Something's missing. Did I have... Oh, how did... Wait a minute. So 7 is DNS. That one must have slid in there, but I definitely have that. Hold on. 6, 5. 1, 2, 3, 4, 5. That's right. 6 was screen. 6.5. I got it. Yeah, there we go. I was like, wait a minute. How is that? So we've done 9 labs today. 6.5 came in, and then the next one would be conditional loops. So, but yeah, the point is this is what the book is. It's all that for all the Linux stuff here, and then over on the Ansible, it's the same thing with the Ansible stuff. It just gives you more to think about on all of these. So, I'm trying to think if we're gonna keep going. I mean, it is 9 at night. I have been streaming for 4 hours. I probably could. Let me check some stuff here real quick. I don't know if we've told you guys about Discord for a while. Well, it looks like we have on Twitch. Hold on. There's Discord on the Twitch side. And here it is on the YouTube side. You guys are welcome to hang out down there. We're almost up to like 30. We're over 3,800, but we're closing in on 4,000. So that's getting pretty good. People just hang out down there. A lot of people are looking for jobs. I was thinking, I was going to actually ask, I don't know if Robodom's still around, but what I was thinking of doing for tomorrow is I might just stream and be on here, and then I'll also be down in the Discord in one of the voice channels. And what I would do then is some of the guys have said that they want to work through, I don't know, I mean, I guess if anybody wants to come in and I'll do... like a mock interview. I'll prepare. I've got a bunch of prepared questions already, but if nobody has to have they won't have to have their face on. But if anybody wants to just sit around and do mock interviews with me, I'll definitely do that for you guys. I think people might like that. I know some people have kind of asked me about that a little bit. And I'll just, have people explain to me, different system stuff and that kind of stuff, and I can do that. Robodom, I'd probably do sysadmin because that's where most people start. I think most people get on the Linux train and sysadmin stuff. So I think that would be good. Because I've walked you guys through like the questions and stuff, and I've walked you guys through that, like the stuff I think you guys need to know. In fact, if anybody's ever looking for that, it's all in Discord, but it's up in the all that stuff's in the meeting notes, and then you go up a little bit in meeting notes, and you find like this was a bunch of them where. These are the things that I think that an admin needs to know. I think it's right here where it says it. So I'm not very far up. What an admin needs to know about a service. And then we started with like NFS. Is it installed? Is it running? Where is it configured? Where are the logs and errors? Is there a monitoring solution? Yeah. I don't think Cole's left that channel in like the last 8 or 9 days maybe. I think he's just been in that channel, like, because every time I go on, because I don't know if everybody can see it like this, but I can just always see that there's somebody in voice channel, and I'm like, oh shit, I guess somebody's always down there, and it's just, he's been there the whole time. When I did this, what a Linux admin needs to know about security, I showed the actual lab, and then these are the things, like, where do we check for alerts? What is an invalid user? How do you add a user? These were all the tasks that you do in the labs, because I just, this is very much like the Socratic method. Like, do I understand, like, I can generate a key pair, but do I know how to generate a key pair with a pass key and how to generate one without a pass key? That kind of stuff. Crunk, I would just tell you, like, for me, because I was a Toastmaster when I was younger. I think I told you guys that I did Toastmasters in high school, and I would not be a college professor if I was not a Toastmaster. There's no way. I wouldn't want to be in front of people. I would have no interest in talking in front of people. But I found that I could talk in front of people if one condition was met, and that was that I was as prepared as I could be. If I know I'm an expert, or if I know that I'm as prepared as anybody can be for something, I am not nervous to talk in front of any group of people, right? I think the biggest group of people I've probably ever talked in front of is 600-700. Doing like sometimes I do the kickoffs for the guest speakers at like the college or something like that, and that kind of stuff. So yeah, like knowing how to talk to people is important. But anyways, where I'm going with that is, just like, here's the thing: don't go off into unfamiliar territory. Like if somebody says, "Hey, what are your thoughts on the new version of this Linux operating system or something?" You might say, "You know what? I don't actually know anything about that. I've been mostly working with like industry supported tools, and those are the things that I can kind of answer." But like, because you will have in some interviews, I've been in interviews like this where you've got somebody who just wants to trip you up. They just want to show everybody they're the smartest person in the room, and that's a problem anywhere you go, right? Like there's always just one or two engineers that are like, I'm gonna get this person. But I don't like, I try not to step in those traps. I'm like, well, I can tell you what I'm good at, right? And I think I told you guys this like last year. So last year I was coming off a project in June, and I had been building out a high performance compute cluster team for there's a college. They had a high performance compute cluster that runs about 1,250 nodes, and they had two guys a guy and a woman. They had two people on the team, and I helped them build back up to 6 other people on the team, so there were 8 total. And then after my year, they funding and this and this and this, I moved back. I work for a company called Redline, so I moved back over Redline. I'm doing a bunch of projects and stuff. But the they ran all their stuff. Oh, where was I going with that? Anyways, I interviewed for a NASA position, right? And this NASA position, the lead for that position is from my company, a guy named Chris. And Chris can't sit in an interview for somebody that's within their own company. That's like a rule that they have. So I had 4 other guys in there with me, and then their manager. And had an interview. I thought it went pretty good. It was about an hour. I thought it was okay. I thought like a couple of the guys were kind of coming at me weird, and like it was kind of like a weird thing. But I thought one or two of them liked me, and then I thought the manager liked me. And then I got a message like a couple days later, and they're like, "Yeah, they didn't want to hire you. They didn't think you were senior." I was like, "Huh, all right." And that's exactly how long I thought about it, and I just went about my day. Kept working on what I was doing, kept teaching, kept doing whatever, and I found out later from Chris, because Chris is the tech lead for that position, that when he found out about it, he goes, "What the fuck are you guys talking about? Why'd you guys pass on Scott?" And they're like, "That guy's not senior," and he's like, anyway, so come about 2 weeks, maybe about a month later. So this was like later, maybe as far as September now, a few months later. I was working on something and I was doing it with whatever these different projects we were doing. And Chris came over to me and he goes, "Hey, that thing that you just did all that documentation for, can I use that?" And I was like, "Yeah, of course. It's in our Confluence page. Do whatever you want." He goes, "Yeah. The guys can't get this thing working." And I go, "Oh, hold on. The guys that said that I wasn't senior, they need some byproduct of some shit that I just wrote that wasn't even what I was actually working on. It was just a byproduct of it. They need it." I said, "Yeah. Tell them who wrote it too." And he's like, yeah, no, I'm definitely doing that. He tells them all the time they're idiots. But I don't know how they voted. I don't know what they did. But they were like, "That guy's not senior." And I'm just like, but it was weird because one of the guys, it was super weird. There's a command when you're using IB Fabric, like InfiniBand fabrics. There's a command to check the all the fabric, right? There's a thing for the network manager. There's always a network manager, at least one, and then they're in quorum and this stuff. And I talked about all this stuff with him. And there was a command. There's a command. I'm trying to think of what it is right now, but it's like you got all your tests you do on the systems like IB status and whatever if there's something wrong. But if the whole fabric is having a problem, you go check the network manager. And this guy asked me for this command, and I said it, and then I talked a little bit about how I would troubleshoot it. And he goes, "Oh, I was looking for this command," and I'm like, I said that command. Oh, whatever, fuck it. Like I wasn't gonna argue with him in an interview, but I said the command first, and then I explained my troubleshooting. But this guy was like, yeah, I was looking for this command. I was hoping you'd know that command, and I'm like, I literally said the command up front. Anyway, it was a couple weird interactions with, and actually it was funny. There was like a bit of a language barrier with a couple of the people, and Chris told me that those guys kind of have problems working with everybody. I'm like, well, I guess I dodged a bullet then, but I just. Again, I will probably always tell the story of the time that like people that were very junior to me thought I wasn't senior, but I don't care. Like I've worked on tens of thousands of systems since then, and in the last few months, and I'm not going to worry about it or let it make me lose sleep. But I will always remember that, don't let anybody like, "Oh, I worked at NASA, so it makes them smart." Because I'll tell you, some of those guys, they don't even know what they're doing over there. And Chris, yeah. Anyways, it's neither here nor there. But anyway, so this is a bunch of our lab stuff. But I'll try to not sit around and be bitter. But also, he was telling me, Chris telling me, he's like, "Scott, you dodged a bullet anyways." Because what I do now, I love what I do now. I just work on a bunch of different projects. But just recently, I went back over to NOAA because I've built all the NOAA systems. So I've told you guys that stuff. I built. I built these. Well, here it is right here. I was a big part of building these. I was on the team, right, of these guys. Which is, again, anything that's released I can talk about, but if it's not released I can't talk about it. But that's how all government stuff is. Once it's in a PR, I can talk about it all I want, right? But that's like a thing that I worked on. I wrote all the Ansible that builds this. So, and I'm back on that system. Once they give me a new common access card, those cards are very difficult to get a hold of right now for some reason. The government's very difficult to do all that. All right, so we got a decision, guys. We could do conditional and counting loops and just keep working on labs all night, or we could just hang out and do Linux stuff and look at the new shop that I built. Hold on, I'm gonna pull this up. I'm gonna pull the where'd that go? Hold on, here, pull those guys up. It won't actually sit there that long. Oh, also, I want to get this info to my buddy that needs it, because I found this. So, I got to pull a bunch of weather data for one of my buddies, and I'm gonna do that here in a little bit. Definitely before I go to bed for sure, but I need to check. All right. I gotta stop playing on my phone while I'm streaming. I won't get anything done. Well, I don't get anything done anyways, but yeah, hopefully, I mean, like if any of you guys are hanging out doing this stuff, hopefully this stuff's like at least it makes sense, because this is all the stuff we're doing. That's like the base of being a sysadmin, and then sysadmin helps you roll over and get into the systems engineering roles, and then you can specialize in the networking and the storage and the security and whatever other things you want. My company just got we just hired another guy. I didn't even know we were hiring for another HPC admin, but I'm always looking for people that are wanting to learn in that space, because my company does train people. They don't train people on Linux, like base Linux. You got to know that already, but they do hire people for high performance compute stuff, which sounds scary if you're not doing it, but it's not that scary. It's all basic Linux. You're still just doing basic Linux. Learn your automation, all these things. I keep telling you guys, do this stuff and you'll get ready, and then the company will pick you up when it's time. But you just have to you just gotta keep working on it. Also, I've had really bad allergies. Some of you guys were around last week when I was like just snotting and stuff, and I couldn't even breathe, and it's like weird. I'm still having a hard time breathing. But I think that's just allergies and stuff. All right. Other stuff I got to do. I got to put together. I'm going to definitely be doing this tomorrow night. I got to put together the security course, because I just stay 1 week ahead on the security engineering. So I'm going to be doing LDAP and some other stuff in there. By the way, people that don't know, if you go on Discord, there are events. Every event in our Discord is free. We have never charged anybody anything for our Discord events. We're not going to. But there's security engineering study group. That's tomorrow. That's actually Treasure put that together. His stuff's really good. He's going through the course, and he did the same thing with the Linux admin course before, where guys were always in there studying and working together, right? So you guys are welcome to be down there. The Linux sysadmin course has 123 people say they're coming. We only have about 40 or 50 though, but it's pretty good. When we do that meeting, I try to get us in and out in an hour. So it's just an hour. We go through stuff. We move fast. And then we go. Then there's a couple hours later, there's a security engineering course. That one's getting more and more people interested. But there's a whole bunch of work with these. So if you come in later, you want to get caught up on all your work, right? There's the writer's room. These are the guys that are, they're going out and building the books for you guys. If you guys don't know, there's free books. And then there's a bash group. Colchis is going to run a bash group. That one's getting big. And then we got 2 conferences coming up that are free. We just do all day conferences, but they're out in August. They're on our anniversary. So there's that. If you guys don't know about the books are free, and the guys are always working on them. So here's, what the books are all about. And I will link these to you guys if you want them. Here are the books. And then the books also link back to all the other stuff. I really like the way they do this. They do it all up in GitHub, and then when they publish it, it just publishes the whole book. And you guys can actually print that book to a PDF and download it if you want. So if you're like, oh, I don't want to look on this webpage for another second, you can actually just come over here and go to print, and it'll print the whole thing as one big giant PDF. So yeah, it was Treasure's little kind of baby, and yeah, all the stuff in there. Massive amount of work went into this. They're still working on it. There's a final project for this one. There's a final project for this one as well, but I need to emphasize it more this next week. There's a final project outline here. Yeah, so they got all that in there. That's awesome. Yeah, I tell you, the guys put in a lot of work on that. Like, if I had to guess, there's hundreds of hours in that book. My time is probably like 40 to 50 hours worth of time building the courses and stuff, but those guys have spent so much time like formatting it and working it into like kind of a workable tool. So man, Ranger hasn't moved in hours, but I can see him breathing, so I can see the little rise and fall of his little chest. Oh, and he moved his paws, and he sat up. I think I told you guys, when Ranger was younger, he used to like run in his sleep, and he would like go like this. It's so funny. It was so cute. He's old now, man. He's almost 14, so he'll be 14 in October. If he can make it, guys. Yeah, yeah. Well, Rodom, you know, it's funny. I'm way closer. Like, I moved an office over. I used to be on the other side of a bathroom here in my house, and I moved closer. So I am a lot closer to the stairs, and then he's downstairs and back through a hallway. So he maybe could hear me better from here, for sure. I am closer to him. Back where I was before, sometimes I would yell for him. I'll yell for him if you guys want, but he's going deaf. Like, it would probably just be super loud to you guys. But I'll yell. Hold on, let's see. All right. Hold on. I might mute this mic because I'm gonna yell loud. Hold on. Let's not be that guy. Hold on. Yeah, that was that. I yelled pretty loud. That dog. He's a good dog, man. We like Ranger, but he yeah, he's conked out, man. Look at him. Look at that dog. All right. Oh, did I fix that thing? Hold on a second. I don't think I ever fixed that thing. Where did I put? Hold on. Hold on, guys. I don't think I need to. I said earlier I was going to fix something and then I didn't. Collections, office. Yeah, there's one other mug that needs to be in here. There we go. Boom. All right. Yeah, because I saw earlier that one of the mugs was missing. Home products. Home. Now I gotta refresh this page. Hold on. Because one of the things wasn't in there earlier. Yeah, there we go. There's the pseudo mug. And then yeah, so now there's all the things. And then I built these today. I feel pretty good about these. One of my buddies already bought those because he wanted it. So Prolog, Professional Linux Users Group, do all the Linux, and then Amaze with Linux is the way in the middle. I think that's fun. For me, it's fun. But anyways, all right. So there's the books. There's the security course. We're gonna be busy all weekend. I'm pretty much be on all weekend. I mean, I got to teach my college classes. I do my study groups on Sundays or Saturdays for my students, and then Saturday nights we just kind of hang out. And then typically when we're done, we just hang out in one of the Linux channels. So after we do our meetings, we'll hang out down there for a bit, and it'll be good. So, what do we want to do here? Do we want to do more labs or do we want to go raid somebody? I guess we got a decision to make here. Do more labs. I could start building stuff for Unit 2 or Unit 3 now, but I probably just a little too beat to do all that. It's kind of interesting the color change that I got here when I went to this one. This looks so much more like Slack to me now than it used to. This is one of our labs we did, and then I drew that out for you guys. If you guys ever want the raw Excalidraws, just let me know, and I'll drop them in there, because Excalidraw is just a .excalidraw file, and then you can open it in Excalidraw yourself, or you can open it however you want. So, yeah, lots of lab info up there for you guys if you want it. So, all right, let's go find somebody to raid. I could be done for the night. But if you guys, hang out, we're always down in Discord doing stuff. We'll go find somebody to raid over on the Twitch side. On the YouTube side, unfortunately, I don't have anything cool. Oh, we're going to Sid Heresy. We're going to go over there because he is working on electronics, and I like raiding him. So we will go over there. For you guys that are going to be here tomorrow, yeah, we'll do some stuff. I'll sit down in the Discord with you guys, and if anybody wants to do some questions and talk about your Linux experience, that's what we'll do. All right, Take care, guys. I will see some of you tomorrow night.